With a question like this, you could either try to factorize, or if that doesn't work, then you could use the quadratic formula. I definitely think that factorizing will work, so let's have a look. We can see that the number 24 can factorize as, you could say, 6 times 4, for example, and as long as the 6 and the 4 can somehow give you a negative 2, then this one can factorize. So we could make two brackets, and we could say x and x, and then 6 and 4. And then to make minus 2, you have different options. You could have 4 plus 6, that gives you 10, so that won't work. Minus 4 plus 6, that gives you 2, so that doesn't work. What about minus 6 plus 4? That works, because that gives you negative 2. And so we want negative 6 and we want positive 4. Then in the last step you can say, therefore, x minus 6 must be equal to 0, or x plus 4 must be equal to 0, and then we can say, therefore, x is equal to 6, or x is equal to negative 4. When they ask you to solve for x and they tell you that they want you to use 2 decimal places, then I can tell you with 100% certainty that this means you need to use the quadratic formula. So the quadratic formula is the one that goes x equals to minus b plus minus the square root of b2 minus 4ac over 2a. Okay, it's a formula that we've obviously used millions of times by now, so we're just going to go fill that in. So we can say x is equal to, and then we're going to say minus. Why? Because there's a minus over there. Then this will be your a, so that'll be your a, this will be your b, and this will be your c. So we're going to put b as negative 3 plus minus, and then we're going to go minus 3 in brackets squared minus 4, and then a is 2, c is minus 3, and then all of this over 2 times 2, and then I'm just going to go ahead and plug that into my calculator now. Oh, sorry, for the plus and minus, obviously you need to choose one, you need to choose your own one, so maybe we'll choose a plus for the first one. And so for the first answer, we should get 2.19. And then for the other one, we're just going to do exactly the same thing, obviously, but now we're going to put a negative in the front. But everything else stays the same. In a test, you don't have to go write it out like this. I'm just doing it, but you could say plus minus like that. And then for this one, you should get negative 0.69. In this question, we have an inequality. Now, it's quite interesting. I've noticed a lot of grade 11s and grade 12s, they just don't like inequalities. So with an inequality, where there's a square like this, you would take everything to the one side. So that's going to give us that'll become a plus 4, and then you keep the sign like that. Some learners ask me, they're like, Kevin, when do we change this little sign over here? Is it when you take the negative over? And the answer is no. You only change the sign when you divide with a negative. So you only change the inequality sign when you divide with a negative. Okay, so we're not dividing with a negative when you take it over to the other side. We're just plussing it onto the other side. So what you would do now is you could factorize this into the two brackets, and that would become x plus 4 and x plus 1. If you need to pause right now, you can obviously do that and just see that it makes sense to you what I've just done there. Okay, and then now this is where some students make a lot of mistakes. Okay, so here's where you got to be careful. So I'm actually going to do it in a different color. This is the incorrect way. Okay, remember I'm saying that this is the incorrect way. Some people are going to comment below the video and they're going to be like, yeah, but sir, you're doing it wrong. But I'm telling you that this is the incorrect way. Okay, so what some students do is they just say x plus 4 is smaller than 0, and then they say x plus 1 is smaller than 0, and then they just go solve both of those, and they say that therefore x is smaller than minus 4, and then x is smaller than minus 1. That is completely incorrect. Okay, so I'm going to put a line through that. That is not how we do inequalities. What we do is we can pretend that this is an equal sign, and we can call, your teacher might call it the critical values. Maybe they don't call it that, but these are the numbers that you put on your number line. So if this was equal to 0, if it was equal to 0, then you'd get that x is minus 4 and x is minus 1. So these are the two numbers that you're going to put on your number line now. So let's go put those two numbers down. Minus 4, minus 1. Okay, so what we do now is you can use the parabola approach. A lot of learners like that. In some of my earlier videos, I didn't used to show the parabola approach, but these days I love to use this approach because I've realized that a lot of learners like this. So what do I mean? We know that a parabola can either be a happy parabola, so you can go like this, okay, or you can get a sad parabola. Let's rather put it over here. Now, how do we know when it's a happy or a sad parabola? Well, if we look at a parabola's equation, ax squared plus bx plus c, all that you must do is you must look at the a. Okay, so the number in the front of the x squared. If a is positive, then we get a happy one. So for this one over here, it's a smiley face. Okay, so this will be if a is positive. So let's write that nicely. If a is positive, then it's going to be a smiling face. Now, if a is negative, then we get a sad face. Okay, so if we look at this parabola here, we know that that parabola there is a positive one. Why? Because look at the a in the front. It's a number 1, so that would be a positive number. So what I do is I just draw a happy parabola going through those two numbers. Okay, and what I then do is I pretend that this is the ocean. You know the ocean where the fish swim in the sea and we go to the beach? I'm talking about that ocean, okay? Now, I want you to think about above the ocean and below the ocean, okay? So, in this area over here, we are below the ocean. So this is below. And then in this area here, we are above and above. Okay, now the question says, where is the parabola smaller than 0? Can you see that? That means parabola smaller than 0. So what does smaller than 0 mean? Smaller than 0 means below. Well, let's do that in green. So then what we do is we come back to the parabola and we see, oh, there it is, it's below over there. So the answer goes from negative 4 up to negative 1. It's this whole piece over here. Can you see that? It's all of that from minus 4 up to minus 1. So you can give this now in two different answers depending on what you prefer. So we could use interval notation, where you would say x is an element going from minus 4 up to negative 1, and we are including those values because they are also including the values over there. If you are someone that rather prefers to use set builder notation, set builder, then you could say that x is bigger than or equal to minus 4 or smaller than or equal to 1. Some learners even write that in a slightly different way, which is, minus 1. My bad, that's minus 1. Now, some learners do it in a different way. What they like to do is they say x is smaller than or equal to minus 4, and, so here's where we can use the word and actually. Some learners don't like to do this, and x is smaller than or equal to minus 1. This is a square root equation. So what we do with a square root equation is we first try to get the square root by itself. But this square root is already by itself. But let me show you an example of something that wouldn't be by itself. Maybe we have something like this. Okay, so if you ever got a question like this, where this square root is not by itself, because this minus x is also there, then what you would do is you would first have to get the square root alone. So you would do this. You see what I mean? So that's what you want to do first. But we've already got that over here. So what you then do once you've got the square root by itself is you're now going to square both sides. So we're going to do this, and then we're going to do that. Now on this side over here, this 2 is going to completely cancel out that square root. Okay? So you're going to end up with just x plus 28. On the right hand side, please be careful, guys. A lot of you, what you do is you just put the 2 into the bracket like that, but you must rather do double brackets, unless you really know how to do it in one step. So then you're going to go multiply that out, and you're going to end up getting x squared minus 2x minus 2x. Sorry, let's do it in the correct order. That's going to give us 4 minus 2x plus x squared. Now all of a sudden we have a normal type of equation where we can just turn it into a trinomial. So I'm going to take everything to the right hand side. Yes, you are allowed to do that. Okay, and I'm just going to simplify now. And here you can use the quadratic formula if you want, but this one does actually factorize quite nicely as x plus 8 and x plus 3. Therefore, x is equal to 8 or x is equal to minus 3. Now, you must remember that with these square root equations, if you want to get full marks, 4 out of 4, then you must remember to do a little check at the end. Okay? It's all of these square root equations. They must be checked at the end. So let's do that quickly. So how do we do the check? It's very easy. You take this number 8 and you plug it into the left-hand side, and you also plug it into the right-hand side, and you see if you get the same on both sides. So if you had to plug, so let's use x equals to 8 first. So if you had to plug 8 in on the left, what do you end up with? You end up with the square root of 36, which is 6. Okay, now if we plug it on the right hand side, you get 2 minus 8, which is minus 6. So can you see that these two numbers are not the same, and we can say therefore x equals to 8 is not a solution. Okay, then we need to go and do a check with the other one. So with this one, we're going to do a check with x equals to minus 3. So you're going to go plug it in on the left hand side first, and that's going to give you 5. Because it's the square root, sorry, let me maybe make that a bit more clear. That's the square root of 25, which is 5. Now we need to go plug it in on the other side, which is 2 minus, then in brackets you put the minus 3, and that also gives you 5. So that one is perfect. So we can say, therefore, x is equal to minus 3. Okay, so the only answer for this question is minus 3. So the way that you could show that in a test is you could just say that x is not equal to 8 or x is equal to negative 3. In this question, we are going to be doing a simultaneous scenario. So I still get so many grade 11s and 12s, and they're always like, sir, this one looks really difficult. How are we going to get the y or the x by itself? Because so many learners have been taught that you always want to get to something like this. Y is equal to 3x plus 1 and y is equal to x squared minus 3x minus 2. Because then they think, oh, then we can just make these two things equal to each other. Now that is correct, but you don't always have to get the y by itself or the x by itself for both. In fact, that only really works in grade 10 because it's not much easier types of equations. But for grade 11 and 12, what you rather do is you just get x or y alone in one of them. Okay? So only get x or y alone in one of them. So you're typically going to choose the more easy looking one. So that's this one. And a lot of learners, they're like, oh yeah, I'm going to get the y by itself. But then you're going to have to divide by 2. And that can get quite ugly because you're going to have like a 3 over 2 fraction here, which isn't very nice. What I would rather say is just get the x by itself because it's already by itself. So you just have to move the 3 over to the other side. So you can do that. Then what you do is you take that now and you plug that into the other equation. So wherever you see x, you're just going to replace that with this 2y minus 3. And so what that's going to look like is the following. You're going to say 2, then you're going to say bracket, 2y minus 3, and then there's also a y over here, so we'll just add that over there. Then you're going to say plus 7 equals, then in brackets, 2y minus 3 squared plus 4y squared. Just like that. You see what I did? I replaced all of the x's with 2y minus 3, and now I'm just going to solve. Some learners don't like this type of scenario, so I'll just put the y in the front. So we'll put it there. Okay? Now it's easy, right? So now we're just going to multiply in. So that's 4y squared minus 6y plus 7. Then we're going to multiply these two together by putting a double bracket. Yes, you can do it the Foster way, but some learners are not comfortable with that, so I'm going to do it this way, like that. So we're just going to go a step further. So that's going to become 4y squared minus 6y minus 6y plus 9 plus 4y squared. Now we just have a basic type of question where we just have to get everything to the one side. So you can choose left or right. I'm going to choose right. So that's going to be, I'm going to take everything to the right hand side. And there's so many different ways that you can do this. I'm just going the longer method because I'd rather do it a bit slower instead of confusing any learners. Okay, so now I'm going to go put everything together. So for the y squares, you would eventually get 4y squared because this one, and this one gives you 4. Then for the y's, you're just going to end up with minus 6y because that's this one, and this one. And then you're going to say plus 2. Now, you can factorize a 2 out if you wanted to. So maybe let's do that, but you don't have to, right? At this step, you could use the quadratic formula. You could do anything right now, but I'm going to just take out a 2. So I'm going to divide everything by 2. So this will become 2y squared minus 3y plus 1. This one can factorize, so that's going to give us 2 brackets, and it's going to be 2y and y. But as I said, you could use the quadratic formula right now. And then this will be a 1 and a 1. And then to make a minus 3, you would have to put a minus here and a minus here. So then we can say that 2y minus 1 is equal to 0, or y minus 1 is equal to 0. So therefore y is a half, or y is equal to 1. We're not done. Now we need to go get the values of x. So to get x, you plug these answers into, you can plug it in anywhere really, but I like to just plug it back into this one over here. So now we're just going to let y equal to a half, or not let, we don't really say let y, but if y is a half, if y is equal to a half, then x is equal to 2 times a half minus 3. You see, I'm just plugging it back into here so I can get x now. And so that means that x is going to be equal to minus 2. And then if y is equal to 1, then x will be equal to 2 times 1 minus 3. And so x is going to be minus 1. And so there's all of our answers. We can say that x is equal to minus 2, x is equal to minus 1, y is equal to a half, and y is equal to 1. This question looks really interesting, and it's the type of question that when you're having stress and you're in that exam, you want to cry, right, when you look at something like this. So let's see how it goes. They tell us that the roots of an equation are this. M, n, and p are positive numbers. Okay, that's important. So m, n, and p are positive numbers. Okay, I don't think the real numbers is that important. The numbers m, n, and p in that order form a geometric sequence. Now the first thing I would like you guys to remember when you think about a geometric sequence and they're giving you letters, like think about this. Let's say I gave you this. Let's see who understands their work. Let's say I gave you that, and let's say I said that that's geometric and I asked you to find x. What would you do? Well, this is where you would say term 2 divided by term 1 is the same as term 3 divided by term 2, right? So we're going to do it with m, n, and p. So we're going to say term 2, so let's quickly write this down, is equal to term 3 divided by term 2. So that's going to be n over m is the same as p over n. I would then use some cross multiplication, and I would end up with n squared is equal to pm. What I would then do is then find the n squared over there, and I would replace it with pm. Can you see that? Because we said here that n squared is pm. So just to make sure you guys understand what we're about to do, let's choose a different color here. So I'm going to replace this n squared with pm, because it's also equal to n squared. And so that's going to say that x is equal to minus n plus minus. Now we're going to replace that with pm minus 4pm over 2m. Now, if you had to simplify inside that square root, it's 1pm minus 4pm, so that's minus 3pm. Okay? Now, they said they want us to prove that x is a non-real number. What is a non-real number? Well, a non-real number is when you have a negative inside a square root. So you can't say, oh, there's a negative inside the square root. That's why it's a non-real number. This whole thing must be negative. So they told us that P and M are positive. Remember that. They said P and M are positive. So we know that this part over here is going to be positive. Why? Because if P is positive and M is positive, then 3PM is also positive. So we can say 3PM is positive. Well, so we'll say bigger than 0, not even bigger than and equal to, because they said that they are positive numbers. So that 0 is not included for all P and M. So for all P values and M values, it's always going to be positive. So if you then put a negative in the front, then that's going to make it negative. So we can say, therefore, minus 3PM will be negative for all P and M. Okay, so this means that we're going to have a negative inside the square root. And so we can say, therefore, X is non-real. Because if this is a negative, then when you have a negative inside a square root, it doesn't matter what happens to these other terms. As long as you have a negative in a square root, it's going to be an error. And you're going to get an error on your calculator, and that is non-real. We are told that this is a geometric series, and they say calculate the value of x. So when it's a geometric series, and they've also told us that there's x's and things like that, you know, like those type of questions we've looked at before, where you have like x minus 4, x plus 3, and they tell you that it's geometric. What you must remember to do is just to say term 2 over term 1 is the same as term 3 over term 2. So let's do that for these three terms. So we could say, we'll start off by saying term 2 over term 1 is the same as term 3 over term 2. And then that's going to give us 90 over x equals 81 over 90. Then we can do some cross multiplication. And so that's going to give us 8,100 equals to 81x. And then by dividing, you'll just find out that x is equal to 100. Now, for question 2.2, they're saying show that the sum of the first n terms is this. Now, I know, guys, when you look at this, you're like, what is going on? But the point is, the way that I do mathematics and the way I would advise is I don't look at this in the beginning. I don't even care what that looks like. What I do is I read this. It says show that the sum of the first n terms. So all I do is I go work out the formula for the sum. And I know that if I do a couple of things, it will eventually look like that. Okay? But your goal is not to look at this and try to figure it out. So what we do, we know it's a geometric. So we can quickly get the geometric formula. Now, some of you might use the alternative formula for this one, which is like this. It doesn't matter. Both are correct. Okay? If you use the ones first, and then use the r's second, or you can use the r's first and then the ones. Just don't switch it around though. Don't use the r. Don't do this. Don't put the one first, and then at the bottom you put the r first. That's not correct. Okay, so I think I'll just go with the top one. Doesn't really matter. It will all work out at the end. And so I'm just going to go fill everything in now. So Sn is equal to A. So A is our first term, which is the x, which we calculated as 100. If you were in an exam and you couldn't get the first answer, maybe just fill in x over there. They'll still give you some marks because they can see what you're doing. So you could have just put an x there if you didn't know what it was. Okay, so then 1 minus. Now we need to work out the ratio. So to work out the ratio, you just say term 2 divided by term 1. And so that's going to be 90 divided by 100. And so that's going to give us a ratio of 0.9. So we'll just put in 0.9 to the power of n over 1 minus, now your ratio is 0.9 again. And so if you had to go put these three numbers, so if you had to say 100 divided by 1 minus 0.9, you're going to end up with 1,000 and then 1 minus 0.9 n. And even if you used the alternative formula, you probably would have had like a negative at the bottom or something like that, and then you would have been able to switch stuff around, and you would have still been able to get to the same point. And then it says hence or otherwise calculate the sum to infinity. So the sum to infinity, we know that that is equal to a over 1 minus r. This is actually a very easy question. I'm very surprised. So a is 100 and r is 0.9, and so the sum to infinity is just going to be 1000. Here we're going to be dealing with a quadratic number pattern. Okay, so quadratic number pattern is the one that has that formula Tn equals to an squared plus bn plus c, and they are going to ask us to calculate it in this part over here. Okay, so for this first one, they want us to just determine the value of term 4. Okay, and it's only for 1 mark, so let's quickly just go figure out what's happening here. So minus 145, minus 122, minus 101. So let's just see what they are adding here. So here they're adding 23. If you didn't know that, you can say minus 122 minus 145. You always take the one on the right minus the one on the left to see how much they're adding. And then you could do the same for the next one. So you could say minus 101 minus 122. While I'm busy recording this now, guys, it's actually load shedding. So, and I don't have like a little torch in my room, so I'm sitting in quite a dark room right now. And whenever I type in the values on my calculator, I can't see the answer, so I have to like tilt my calculator to my white screen on the laptop just to get a bit of light. So, okay, that's 21. Okay, so that's 21 over there. And if we then look at the difference there, it's negative 2. Okay, so we know that with a quadratic, these numbers remain constant, right? So I could go negative 2 again, which means that this number here is a 19. So then, if I say minus 101 plus 19, then that means we would get negative 82. And so term 4 is negative 82. All right, 3.2, find the formula. Okay, so we know that once we have all of these numbers, well, we actually only just need these numbers in the beginning. If you have those numbers, then you're good to go, because you must just remember these 3 formulas. And so what we do now is we start at the very bottom. So we start off with 2a is equal to minus 2. Therefore, a would be minus 1 if you had to go solve that. Then we go to the next one. So that's 3a plus b equals to 23. So that's going to be 3 times minus 1 plus b equals to 23. And if you had to solve for b, you're going to end up getting 26. And now we can go to this last little formula, which is a plus b plus c equals to minus 145. And so we already have a as minus 1. We have b as 26. And then we've got that. And so then we can solve for c, and we should get minus 170. So now we have a, b, and c, so we can just go fill that in over there. So Tn would be equal to a, which is negative 1, b, which is 26, and c, which is minus 170. And that's the formula that they asked us to find. Now, these types of questions can be quite intimidating at first, this one over here. So it says, between which 2 terms in the quadratic pattern will there be a difference of minus 121? Okay, so some students struggle to figure out, like, what do they even mean? Like, where is this minus 121? Is that minus 121 going to be in this pattern over here? No. So let me show you guys. They're saying between which 2 terms of the quadratic number pattern. So the quadratic number pattern is the one at the top. Okay, so let's imagine we go on for some time. We don't know how long we're going to have to go for, but eventually there's going to be these 2 terms next to each other, and if you look at the difference between them, it's going to be minus 121. And so in this pattern over here, eventually there's going to be a number that is minus 121, and we just need to go find that, and that's pretty easy. The reason that that's pretty easy is that this number pattern here is, okay, so if you're in grade 12, I'm going to call it an arithmetic number pattern. If you are in grade 11, you probably might still be calling it a linear number pattern. Okay, now bear in mind with me here. In grade 11 and 12, they show us two different formulas to calculate an arithmetic or a linear number pattern. So typically, not always, but most of the times, in grade 11, you're going to use for a linear number pattern, you'd typically use like an plus b. Look, your teacher might use different letters, but it's usually something like that. Then in grade 12, for the grade 12 learners, we normally switch over to using a plus n minus 1 times d. Okay, so I'm going to do both, of course, because there's definitely grade 11s and 12s watching this. So I'll do both for you guys. So we're working in this number pattern over here now, because that's a linear number pattern. So I'll give you guys a bit of a summary. This top one is always a quadratic. The second one is always a linear or arithmetic, depending on what you prefer. And then the bottom just stays constant. That'll always happen for these quadratic patterns. Okay, so let's use the grade 11 approach first. So let's say grade 11. Then we're going to use Tn is equal to an plus b. So the way it works in grade 11 is you look at the difference. So what's the difference? Well, some people would say 2, but I would say that's not correct. It's minus 2. It makes a big difference. So if you're going from this side to this side, it's minus 2. So that is your a value in this type of pattern. And then b, so now there's different ways of finding b, okay? There are different ways, but what b, the way that I like to do it is b is always term 0. This is term 0. Some of you are like, Kevin, how the hell do we find term 0? You can just imagine we had to go back to this one. This would be term 0 because this is term 1. So term 0 would be 25, right? So I'm going to say plus 25. Okay, so that is the grade, that's how we'd get the formula in grade 11. Now, what about if we are in grade 12? Well, what you guys are going to do is you're going to do the following. For the grade 12s, I'm actually going to do it up here. I think I'll have a bit more space over there. So you guys are obviously going to use the arithmetic formula. It's actually the same thing. I don't know why we get taught two different ways. But, okay, so the way it works in grade 12 now is it's a little bit different. A is term 1. So term 1 in this pattern is 23. N we don't know. The common difference each time is minus 2. Please put it in a bracket because it's a negative number. That causes a lot of problems for learners. I've seen that. So, because what some learners do is they just do this. And then they think, oh, it's just minusing. But they forget that it's multiplying. Okay. So now we can just multiply this minus 2 into the brackets. That becomes minus 2n plus 2. And then you can go work it out as 25 minus 2n. And then if you want, you can just put the n in the front, like that. And then we get the exact same, okay? So grade 11 and grade 12, of course, we'll get to the same answer if it's the same type of pattern. So now that we have that, now it doesn't matter if we grade 11 or grade 12, now it becomes the same. So we need to work out in that pattern, where do we find a term that has minus 121. So we're going to substitute minus 121 into the place of the Tn. Okay, whether you're using grade 11 or 12 doesn't matter right now. So I'm going to erase the grade 11 method. I'm just going to write that formula down. And so we want to know where would we find minus 121. So we're going to put minus 121 over there. And now we're just going to solve for n. So I'm going to take it to that side. And then that's going to go to 146, right? Yeah. And then we're just going to divide that by 2. Sure, guys, I'm really struggling here with this no light in the house. Like every time I have to look at my calculator, I have to tilt it towards the white laptop screen just to get a bit of color, a bit of light. 146 divided by 2 is 73. Okay, so n is equal to 73. So that means this is term number 73 in this pattern. Now, some students say, okay, Kevin, so what does that mean? Are we going to choose like term 75 and 76, or 72 and 73, or 74 and 75 in this pattern over here? It's very easy. Have a look here. term 1 in the quadratic goes diagonal towards term 1 in the in the linear pattern. Okay, term 2 over here goes diagonal to term 2 over here. So if this number here is term 73, then that means this is term 73, and then this would be term 74. So that's the answer. So it's going to be term 73 and 74. So with this last question over here, it says what value must be added. Now that already starts to give some of us anxiety, right? What value must be added to each term in the number pattern so that the value of the maximum, oh my goodness, some of you are like panicking right now. How do I know this? Oh, I've just done this for long enough with students. I know how you guys can freak out for these little things. It's perfectly normal. There's nothing wrong with you if you're freaking out right now. A lot of learners freak out when they read these types of words. Okay, so don't worry, it's normal. What value must be added to each term in the number pattern so that the value of the maximum term will be a 1? Okay, so guys, the way it works with these quadratic number patterns is what type of graph. It's like, Kevin, why the hell are you talking about graphs right now, dude? Like, these number patterns are enough on them by themselves, and now you suddenly bring in functions. Not cool, dude. But guys, just hear me out. So this is a parabola. Can you see that? That is actually a parabola. It's like, yeah, but Kevin, where's the x's, dude? No, that is a parabola. A parabola is anything that has like a square as the highest exponent. So like, for example, r to the power of 2 minus 3r minus 4. That's a parabola because it's got that r squared. T to the power of 2 minus 3t minus 7. That's a parabola. So this is a parabola, right? I hope we can agree on that. Now, you get two types of parabolas. You get happy parabolas. It's like a smiley face if you didn't notice. And you get sad parabolas, which face downwards. And the way that we know what it is by just looking at this number in the front. If it's negative, then it's a negative or sad person. If it's positive, then it's a happy or positive, happy person. So this would be the happy one, and that's when it's positive. Okay, so we know that this one's negative. So we know that this quadratic pattern, if you had to go plot all of these on a graph, for example, it would be sad. So we definitely realize that it does have a maximum. So that's where they're getting their maximum from, guys. That's all that they're talking about. And we know that if we have a parabola, in grade 11, we learned that to find the turning point of a parabola, you can just use x equals to negative b over 2a. But now we're just not finding x. Now we're just going to go find n. That's the only difference, you see? We're just finding n, which is the term. If you want to be fancy in grade 12 learners, you can even use calculus right now if you want to find maximum. And that would be by making the first derivative. You would make your first derivative equal to 0. That's only for grade 12. Grade 12 learners. Okay. Grade 11s, just use minus b over 2a. Grade 12s, you can also use minus b over 2a. I know a lot of you still do that. That's fine. So that's where we're going to find the maximum. Don't worry about this added to make a 1. We'll sort that out later. For now, we're just going to go find the turning point or the maximum for this one. Okay, so let's go do that quickly. So we're just going to go use n equals to minus b over 2a. So n is, and then we can use this formula. So this is your a, this is b, and this is c. So b is 26, so we're going to say negative 26, because there's a negative over there. And then a is minus 1, so we're going to say 2 times negative 1. And that's going to give us 13. Now that's not your answer. That's saying n is 13. So that means position number 13. Like this is position 1, this is position 2, this is position 3, this is position 4. They said that the maximum value is at position number 13. But we don't know what that maximum value is, but we know that it's at position number 13. Okay? So to find it, it's very easy. We just use this formula, and we're just going to go find term number 13. And let's just quickly say here, sorry, this is position 13, and we don't know what the value is. Okay, so we're going to go find position 13, which is, some students mess this part up. They go like this. That is incorrect, because although that wouldn't really give you a problem. Oh no, sorry, the incorrect thing, my bad. What they do is this. They put this negative inside the bracket. and then this whole term becomes positive. But guys, it's only the n that goes in the bracket. Only the n. See there? So it looks like that. Makes a difference. Some of you are like, oh, Kevin, seriously, come on, dude. But trust me, it makes a big difference. I've said dude a lot in this video. I just realized like 3 times. Maybe I'm going through a midlife crisis and I'm trying to be cool. I don't know. So term 13. Oh, where, brah? So, okay, 13. I'm just messing around. 26 times 13 minus 170. I get some really interesting comments. Learners use terminology that I'm like so not used to. Like the other day, someone said I'm a clutch. Or what? No, how did they say? This came in clutch or something like that. I don't know. I found it quite funny. I had to research what it meant though. I remember the first time someone called me a goat. I was like, that's pretty rude. But I realized goat's pretty cool. So it's pretty nice to be called a goat these days. Some people even call me goated. They're like, bruh, you goated. Okay, Kevin, let's get back into business. Okay, so if you had to go work this out, there we go. Okay, so if you had to go work out term 13, you're going to get negative 1. So that means that the maximum value that this parabola would ever reach is negative 1. So for example, if you had to go draw this parabola on a graph, at the x value of 13, or the n value of 13 if you want, the y value, or the term value, would be negative 1. Okay, it makes sense. I mean, look how negative all of these values are. So the maximum that it would ever get to is about negative 1. Now they said, what value must we add to each term in the pattern so that the maximum is 1? Well, at the moment, it's minus 1. So what must you add to make it a positive 1? Well, you can just add 2, right? Think about it. If this graph is at minus 1, if you just add 2, then it's going to move 2 places up. And that means that the minus 1 is going to turn into a positive 1. So the answer for that question would be a 2. So here we have a linear pattern. Now, linear is also arithmetic. Okay? It's quite surprising that they use the word linear. Normally they use the word oh, geez, what happened there? Usually they use the word arithmetic instead of linear. Okay, but there it is. So they want us to determine term 51. So to do that, we need the formula. So that's going to be, we know arithmetic is a plus n minus 1 times d, where a is term 1, so that's 5. D is your common difference, which is 2. Then go and multiply everything out, and that's going to give us 5. Then I'm going to multiply the 2 into the brackets. That's 2n minus 2. And then we can just neaten that all up and say 3 plus 2n, or 2n plus 3. It doesn't matter. But we can see how they're using that a little bit later in the question. Okay, so we've got the formula. So to determine 51, or term 51, you're just going to go sub in 51. And so term 51 will give us 105. 105. So there's our answer for that one. Now, when some of you read the next question, you're like, oh, these people are so stupid. They just asked the same question twice. But if that's you, then you carefully need to just think about this. So in the first question, they're asking for term 51. In the second question, they're asking for the sum of the first 51 terms. Some of you are still like, yeah, dude, it's the same thing. No, it's not. So if we have a sequence like this, this is just an example sequence. If I say find T5, T5 is this one. Okay, but what if I say find the sum of the first 5 terms? Then I'm asking you to go add all 5 terms together. That's what it means. Okay, so there is a difference between these two questions. Alright, so they want us to calculate the sum. Okay, so we know that it's arithmetic or linear, so we have a formula for that. You know this one, hey guys? Okay, so we just go fill in, we want to find term 51, or the sum of the first 51 terms, so we just do 51 over 2. So 2 times 5 plus 51 minus 1, and then the common difference is 2. There we go. Go ahead, type this all in on your calculator, or do it in your head if you're cool like that, but I wouldn't advise it. Alright, and that's going to give us 2,805. So the sum of the first 51 terms is going to be 2,805. 4.3, write down the expansion. Ooh, that's an anxiety word. Expansion. Write down the expansion of this. Show only the first 3 terms and the last term. Okay, not difficult at all. The way that these sigma notation, some students do not like sigma notation, but the way it works is the following. To find term 1, you're going to plug in whatever this number is. Now that number is not always going to be a 1, but in this one it is. But if there was like a 2 over here, then you would, to find term 1, you would still plug in the 2. This doesn't mean term 2, for example. Okay, so that number there is a 1, so we're going to go plug in a 1, and so that's going to give us 5. So term 1 is 5. Although, I'm being very silly, we already know what the first 3 terms are. Although, we wouldn't have known that these two are linked, maybe. So, maybe we didn't know that. So, term 2, now what you do is you just increase this number by 1. And that's going to give us 7. Okay, we can see we're getting the same numbers, but I mean, maybe we didn't see that. So, let's pretend we didn't see that. And then term 3, we just plug in, we increase this number again. So, that's a 3 this time. So, that's 2 times 3. Plus 3, and that's going to give us 9. Okay, so we have the first 3 terms. So that's what they wanted. They want us to say 5 plus 7 plus 9, because that's the expansion. And then they want us to go plus, and then dot, 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 dot. You don't have to say, we don't get taught exactly like how to do this part. Like maybe some of you just went like that. I'm sure that'll be fine. But let's just say plus for now. Now, they also want us to show the last term. Okay, now, many learners think that this number here represents how many terms there are. That is only true when this number at the bottom is a 1. But sometimes what they do is they'll put like a 5,000 over here, and then they'll say n equals to 2. Then there are not 5,000 terms. So how do we work out the number of terms? In general, or like in all of the scenarios, you take the top number, so let's just say number of terms, equals the top minus the bottom, and then just add 1. That's a little formula to do that. So how many terms do we have here? Well, top number minus the bottom number, and then plus 1. So in this case, it's 5,000. But don't always think that it's that number. Okay, look out for that. So there are 5,000 terms. So if I want to know what that 5,000th term is, I'm just going to plug 5,000 into the formula. So term 5,000 is going to be 2 times 5,000 plus 3. And so that's going to give us 10,003. So we can just go 10,000, and 3. Alright, and then the question that probably scares many of us. I know I would be scared as a student if I saw this, but with practice it does get better. And what I try to tell learners is, don't look at the question and think, oh, it looks so challenging. Like, just start the question. Try not to even think about it. Like, just start the question, and it can sometimes just flow. You'll see what I mean now. So, when I look at this, I don't know what's going on. I'll be very honest. But let's see what they say. Hence, or calculate the following. All working details must be shown for 4 marks. Okay, so, I mean, there probably is like some really fancy ways that we could do this one, but I'm just going to go do it the very basic way. I'm going to go calculate this one. And then I'm just going to go calculate this one. It's as simple as that. So let's go do this first one. So we know that the sum is equal to, because it's arithmetic. How do we know it's arithmetic? Because we saw earlier here, this was the pattern, and that's arithmetic. So that's going to be, and they did say it's a linear pattern, of course. So then we're going to say 2a plus n minus 1 times d. And so to work out the sum of 5,000 terms, remember, we're not saying it's 5,000 terms because of that. It's because 5,000 minus 1 plus 1 is 5,000. Okay, so we're going to do this. A in that one was a 5. And then 5,000 terms minus 1. The common difference between each number is 2. Let's go ahead and plug that all in. It's quite a big number. 2, 5, 0, 2, 0, 0, 0, 0. Okay, so that's this part complete. Now we can just go do this part again. It's quite weird that they're asking that. It's very easy actually. So this one is a brand new one, so we need to go see whether it's arithmetic, geometric. We always need to check for that. Yes, there are ways that you could see very easily, but I think the safer option is just to always do our safety checks. So term 1, to find term 1, you just plug in whatever this number is, which is a 1 in this case, and that's going to give us -3. Then to find term 2, you just plug in a 2. Well, you increase whatever this number was by 1. So that's going to be like this, which is now -5. And then term 3, we're going to get -7. Okay, so it's also an arithmetic pattern. Can you see that? It's just going -3, -5, -7. So it's also arithmetic. So I'm going to calculate it up here. So we're just going to use the same formula. Now, how many terms are there? Well, you take the top number minus the bottom number plus 1. But that's just going to give us 4,999, because when this number is a 1, then this number is the number of terms, but only when it's like that. Okay, so we're going to do this. And then A is -3 in this pattern. I'm just using this formula again now, guys, but on this new pattern. And then 4,999. And then the common difference is, now we're going -2. Can you see that? -2. Go ahead, type this all in on your calculator. Okay, and this one gives us a negative. Nothing wrong with that. It's like, Kevin, how can you add numbers together and get negatives? Guys, if the terms in the sequence are negative, then by adding them, you're still going to get a negative value. But yeah, Kevin, it doesn't make sense though, because I mean, you're adding the numbers. So -2, 9, 9, but if you say so, 9, 9. Sorry guys, I'm in a funny mood today. So 2, 4, 1, 2, 3, 4, 5, 6. Okay, now they just want us to add those two values together. See, they just said add them together. So we'll do that. 2, 5, 0, 2, 1, 2, 3. So can you see, guys, when you first glanced at this, let's get real, you got a bit of a fright. But come on, this is not a difficult question, right? 3, 4, 5, 6. Okay, there we go. Now we can just go type that all in on the calculator. And we get 20,001. So in this question, we have a hyperbola. And the first question says, write down the equations of the asymptotes. So remember that your asymptotes is this one over here and this one over here for a hyperbola. Because if we draw a random little hyperbola, this moves the graph 3 places to the right. So that would be at x equals to 3. And then this moves it 2 places up. And so this would be y equals to 2. Some students struggle with, is it x or y? Well, what I told them to do is, if you follow this line, as soon as it hits the axis, what axis is that? That's the y-axis. So the y is equal to 2. And if you follow this line, as soon as you hit the axis, you're hitting the x-axis. So it's x equals to 3. Okay, so let's just answer this for these people. So x equals to 3. And y equals to 2. Done. Write down the domain of f. So the domain of a hyperbola is always very easy. So it doesn't matter which quadrants we draw this thing in, but I'll keep it correct just for any of you who might get a bit confused. So we're going to draw it later. They are going to tell us to draw it. But for any hyperbola, the domain, okay, so remember the domain is the x values. So the domain is always going to be everything except this asymptote. I'll show you why now, but you can just say that x is an element of any real number, but x cannot be equal to 3. I will explain it now. And then if you prefer to use interval notation, you could say, or I mean, you could have said it like that, sorry, or you could say like, x is an element from -infinity up to 3, or from 3 up to infinity, something like that. Okay, so let me explain. Domain is the x values, right? So let's say we started over here, Now I want to see, can you make this green dot? Can you slide this green dot all the way from the left-hand side to the right-hand side without ever having to lift your pen off the paper? So for example, if you slide it this way, you have to follow the graph though. Whoops, can you see we're getting stuck? How are we going to get to the other side? We can't get to the other side because there's a dotted line. This dotted line is the asymptote, and you can't get past that. So what happens is that we have to jump over, and then we carry on over here, making our way to the right-hand side. And now we have arrived. So we started here, we arrived at the other side, so we were able to do it, but along the journey, we had to jump over this dotted line. So we can say that x could have been any number, because we could have gone as far that way as we wanted to, and as far that way as we wanted to. So x can be any number except for 3, because at 3 we had to jump over the dotted line. Okay? And range works exactly the same, but with range you just you just go from the top to the bottom, or bottom to top, it doesn't really matter, and then you see if you can go all the way. Okay, so we've done that one. Alright, for the next question we have to determine the coordinates of the x-intercept. So remember, to find an x-intercept, that's where you always make y equal to 0. So we go to the original equation and we make y equal to 0. Okay, now there's multiple ways that you could solve this, but I'm going to take this over to the left-hand side, like that, and then I'm going to do cross multiplication. So that one can be multiplied there, and this x minus 3 can be multiplied onto that side. So that's going to give us 1 equals to 2, and in brackets x minus 3, and so 1 is equal to 2x minus 6, so 2x is going to be equal to 7, and then x would be equal to 7 over 2. Now guys, you know what's really weird? I don't know if some of you have noticed this. In our question papers, in the beginning of these question papers, they always tell us, please round answers to 2 decimal places. But then when they do graphs and stuff like that, and they end up with these fraction equations, or these fractions, sorry, they never round it off. They just leave it as a fraction. I would imagine that they would have changed these to like 3.5 or something like that, but they never do on the memos. It's so weird. Like, come on guys, you said 2 decimal places for all questions, unless stated otherwise, but you didn't tell us otherwise over here. So, quite weird, eh? Quite interesting. If you've ever picked up on that, yeah, you've got a valid point. So, where were we? So the x-intercept is 7 over 2. So say 7 over 2, but then also remember that you must fill in the y, and the y was 0 at that point. Okay, the next question, find the y-intercept. Okay, so to find a y-intercept, now we make x 0. Okay, so we're going to go make x 0. And then you can just go work that out. And that's going to give you 7 over 3. So you could then say that the y-intercept, your x is 0 and the y is 7 over 3. And lastly, this is quite a nice basic question. It's like a nice entry-level graph question. So it says, draw the graph. Okay, so to draw a hyperbola, we need the asymptotes and the intercepts, all of which we have found in this question, so that's good. So the asymptotes, well, this moves the graph 3 to the right. Remember, the x is always opposite, so when it says x minus, it moves it right, and when it says x plus, it moves it left. Weird, hey? So that's x equals to 3. Then the y asymptote is moved 2 upwards. That's not opposite, that's normal. So that's y equals to 2. Then we need, now students always say, yeah, but Kevin, my teacher back in grade 10 told me that you have to look at this number to be able to see which quadrants you're in. Guys, you don't have to do that. If you just get your x-intercepts and your y-intercepts, it'll do it for you. Okay, so now be careful. The x-intercept is 7 over 2, so go work out the decimal value of that, because otherwise you won't know if it's bigger than 3 or smaller than 3. So the decimal value of 7 over 2 is 3.5. So that's bigger than 3. So you're going to put your dot here. You're not going to put your dot there. Okay, that's going to make everything wrong. So your dot's going to be over there, and you can fill it in as 7 over 2 and 0. Then you're going to go fill in your y-intercept. So go work out the decimal value of that, just so you can see if it's bigger than 2 or smaller than 2. But that's going to be 2.33. which is bigger than 2. So you're going to plot it there. And there we go. So these are the two quadrants we're in, this one and this one, because those are the only quadrants that will allow us to have an x-intercept there and a y-intercept there. See, guys, it's very simple. So now you just go draw it, and like that. Done. Here we have a log graph that has been drawn, and they give us a point, and they say calculate the value of k. Okay, so that's easy. It's a point on the graph, and k is just the x, and we know that the y is 2. So we can take this original equation, and so we know that the y is a 2, but we don't know what k is, so we just do that. Now, some students do struggle to remember how to rearrange a log graph, but you start with this number, so 4, then you say to the power of this number, and that's going to be equal to this number, okay? And that's going to be k, and so that means that 16 is equal to k, so k is 16. Now it says determine the values of x for which this graph is bigger than -1 and smaller than 2. Okay, so these are y values, -1 and 2. So let's quickly go find the y values of 2, which would be here, and -1 would probably be here. So they want to know between which x values is the graph in between those. Okay, so if I had to draw dotted lines going across, they want to know where's the graph inside here, in between those two. So if I had to highlight the graph where it's between those, it's there. Can you see? Because inside that area, it's between those two red dotted lines, right? So what we need to do is we already know the x value over here. So we know that that x value is 16, because that's what we got in the previous question. But we don't know the x value here. But we do know the y value is -1. So we can just tell this graph, hey graph, did you know that your y value is -1 over there? But can you just tell us what your x value is, please? So now we just reverse everything again. So we say 4 to the power of -1 equals to x. And so x would be equal to, sorry, let me not switch that around. Some students panic when I do that. So x would be 1/4. So that means the x value here, whoops, the x value here is 1/4, and the y value is -1. So remember, it's in this little area here where the y values are between those two dotted lines, because they want the y values to be bigger than -1 but smaller than 2. So the answer will be whenever x is bigger than or equal to 1/4 but then smaller than or equal to 16. So it's whenever the x value is from here up to this x value. Okay. If you prefer interval notation, you could say x is an element going from 1/4 up to 16, like that. Okay, 6.3, write down the inverse. Now some students get a bit confused between this and this. Okay, so this one is inverse. This one is first derivative, which is part of calculus. Okay, so don't get those confused. Here they want the inverse. So to find the inverse, you're just going to write out the original equation. You're then going to switch x and y around. And then you're just going to get the y by itself again. So we're just going to reverse log again. So that's going to be this one to the power of this one equals to this one. And guys, whether I do it that way or that way doesn't really matter. Okay, that's not important. But there's the answer. Y equals to 4 to the power of x. So remember, with inverse, step 1, you just switch the x's and the y's around, and then you get the y by itself again. And that's it. This, by the way, is an exponential. And we should know by now that the inverse of a log graph is an exponential. Let's quickly write that down. A log is the inverse of an exponential, and the exponential is the vice versa. You know what I'm trying to say. Log, exponential, exponential log. Right, now here's one of these questions that just just gives you a headache, right? And if you are a student that is still struggling with these types of questions, you have two options. Either try to find as many questions like this as you can and master it, or just leave them. Like, they're not going to count that much in your test. I mean, this exam, it only counts 2. So don't lose sleep over those questions. Rather focus on the other areas if you just really, really, really cannot get it. Because I do know a lot of students do really struggle with that. Okay. And even like those questions where they talk about K and roots and, oh my goodness, I know you guys don't like those. They're really challenging. Okay, but let's give this one a go. I have got a few little techniques I'd like to share with you for this one. So it says, for which value of x will this times this be this? Okay, now let me explain in a very simple way to you guys. Don't look at what they're giving you right now. Let's first go to the very basics, like literally grade 4. We're going to go back to grade 4 right now. They want you to multiply these two things together, and they want the answer to be smaller than 0. So they want you to multiply these two things together to get a negative answer. That's what smaller than 0 means. Okay, so what we do is I like to do this. I say, okay, so the two things we're going to multiply together are x and the inverse of x. Actually, I was thinking this question's actually a little bit easier. Check this out. If we go x times the inverse. Now the inverse we already worked out in the previous question. Y equals to 4 to the power of x. So y equals 4 to the power of x. And they want that to be a negative. Now, they sometimes like to ask this in like your normal exams, in like question 1, for example. They'll be like, x minus 1 times 3x smaller than 0. And then students struggle because they're like, yeah, but I can't solve this one. It doesn't work. It's giving me an error on my calculator, and I can't make this one equal to 0. Guys, you are correct. This thing cannot be solved. It can't be made equal to 0. You can actually try something. You must realize that this is an exponential, and it's a normal exponential. So it's just like your standard exponential that goes up. And even if it goes down, it doesn't matter. The point is that no matter what x value you plug into this exponential, it'll always be positive. Always. It'll always be positive. Okay? So what you tell the teachers, you'll say that this 4x is going to be positive for all x values. Or you can just say for x is an element of R. It's always positive. So if this is always positive, then what must this part be? So that when you multiply these two terms together, you get a negative number because they want it to be smaller than 0. So if this is always positive, then this would always have to be negative. So we can tell them that x must always be negative. So that's your answer actually. X must be smaller than 0. Here are all the questions that we are going to be doing in this functions exam question. So you can just take a look. Maybe you want to pause the video, but I'm going to be doing each question on a new slide just so we have a bit more space when going through. So here's the first set of questions that we're going to do. So we are told that we have this graph, f of x, okay, so that would be the parabola, and the parabola cuts the x-axis at B and D, C is the turning point, line E has an angle of inclination. Okay, so everything that they're telling us here is already shown on the diagram. So it says for the first question, write down the coordinates of B and D. So B and D are just your x-intercepts, right? So we can to find your x-intercepts, we know that we can just make y equal to 0. And so we're going to have f of x equals to x plus 4 and x minus 6. Now just stop here, because what a lot of learners would do now is they would first go multiply these two brackets together, and then they would end up factorizing again. And what will happen is you're going to end up right back at these brackets anyways. So we can actually just go straight to the answer now. We can make y equal to 0. And then we can simply say, therefore, x plus 4 must be 0, or x minus 6 would be 0. So x is equal to minus 4, or x is equal to 6. Now, when you give those coordinates, so you'll tell them that B is minus 4, but don't just say minus 4, say minus 4 and 0, and then tell them that D is 6 and 0. The next question says calculate the coordinates of C. Now, there's a grade 11 and a grade 12 approach here. I'm just going to use the grade 11 approach, but for any grade 12 learners watching this, you can use calculus, and you can make your first derivative equal to 0 if you wanted to find this point over here. But as I mentioned, I'm just going to use the grade 11 approach, which is just to say that to find the x value of your turning point, you just use minus b over 2a. But now I do need to go and multiply this out first so that I can see what my a, b, and c will be. So let's go multiply that together. So that's going to give us x squared minus 6x plus 4x minus 24. Then I can just neaten that up to become x squared minus 2x minus 24. And now I know what my a, b, and c are. So we can say that x is equal to minus b, so that's going to be minus, and then b is minus 2, over, and then it says 2a. And so a is just equal to 1. And so if you had to work this out, it's going to be 2 divided by 2, which is 1. Okay, so that's not the answer, that's just the x value of that turning point. To find the y value, you just need to plug that back into your equation. It doesn't matter where you plug it though. You can plug it into this one, or you can plug it back into this original. It's all the same thing mathematically. So I'm just going to plug it into the very original equation, so that'll look like this. And so that's going to give us negative 25. So we can then fill that in here as negative 25. Then the next question says write down the range. Okay, so range is your y values, and you always want to go from small to big. So what that means mathematically is from the bottom to the top. Okay, so we always want to write our range from the bottom to the top. So we can say y is an element, and we're going from minus 25, which is included, and then these arrows just keep going forever and ever and ever, and so we're going to go all the way up to infinity. If you prefer to use set builder notation, you would say y is bigger than minus 25. You could actually just say that y is bigger than or equal to minus 25. Now we're on to the next question. So 7.4 says, given that theta is equal to 14,04. So let's fill that in over there. 14,04. And the tangent to f at t is perpendicular to AE. Okay, wait, what? Oh, the tangent at f. Okay, so let's draw in a little tangent to f at t. So we know that a tangent would be a line that would do something like that. Okay, so it's a tangent, so it only touches there at one exact point, and they've told us that that tangent is perpendicular to AE. So this is AE. So they're telling us here that this little angle here is 90 degrees. So they're saying, sorry, I've messed this up here with the marker location. There we go, I fixed that up. So that's 90 degrees. Now they want us to calculate the gradient of AE correct to 2 decimal places. Now this question's a bit weird, and I can tell you now that it annoyed some learners who wrote this exam, or this question in an exam, and it might be annoying you right now because you're like, wait a minute, dude, why are we talking about angles and things like that when we are busy with paper 1? Isn't that part of analytical geometry? Well, yes, guys, sometimes they do a bit of an overlap. Sometimes you'll get a bit of paper 2 content in paper 1 content. So don't panic, okay? What I want to remind you of though is that whenever you get an angle, so let's go angle, I instantly want you to be able to think about gradient, because gradient can be converted into angle, and angle can be converted into gradient using tan. Remember, this has to do with like inclination angles and all of that. So think about that. Angle can always become gradient, and gradient can always become angle. And the way that you link them is by using tan. You know, like sin, cos, tan, but we specifically use tan. So if you have the gradient, then you can say tan of, well, let's actually say if you have the angle, so you can say tan of the angle, that'll give you the gradient. And if you have the gradient one day, just in case, then you say shift. You say shift tan gradient. That's where that -1, it's shift tan. And that would give you the angle. So that is the link or the relationship between gradient and angles. Okay, so what this means is that if we know this angle over here, we know its angle above the horizontal. See, we've got that angle above the horizontal. So that technically means we could work out the gradient of that line. And it's easy to do, and that's why this is only 1 mark. So we would use this one here. So you would just say that the gradient of line AE is going to be tan of 14.04. Now they've chosen a really weird number, 14.04, so I have a feeling it's going to give us a perfect answer. Yeah, sort of. 0.25. It rounds off quite nicely. 0.25. Oh, and they did say correct to 2 decimal places. Okay, that's nice. So 0.25. Excellent. Now for 5 marks, this looks good. Calculate the coordinates of t. Now for this question, I'm going to show 2 different methods. There is a grade 11 technique on how to do this, which I think the grade 12 learners you should also watch. It's really good and you can use it and it's very good, it's like very helpful. And then I'll also show a grade 12 technique, which for the grade 11 learners, you must just ignore that one. So I'm going to start off with the grade 11 technique. Okay, so what you do is the following. What we must understand is that, okay, so if I have a parabola, now listen carefully, this is very valuable. If you have a parabola and you have a line going through the parabola, how would you find out where these 2 lines or these 2 graphs intersect? Well, you would make the 2 equations equal to each other, right? Okay, but how many solutions does this one have? Well, it cuts once and twice. So this one has 2 answers. Okay, what about this one? What if this line goes here? How many solutions would this have? Well, this would have no solution because these 2 don't even touch each other. Okay, now what about if it's a tangent? Let's draw that a little bit better. What if it's a tangent? Then in how many different places does it cut? Well, it only cuts once, so you only want 1 solution. Okay, now I'm going to show you a mathematical way of how you can find only 1 solution. So what I'm going to do, can we all agree that these 2 graphs, the tangent and the parabola, they are touching each other. So they are equal, they are going into each other. So how can you find out where the 2 graphs go into each other? You make them equal. So we're going to make f of x equal to the tangent's equation. Okay, but now we don't have the tangent's equation, but what we do know is the following. We know that the gradient of AE is equal to 0.25, right? They also told us that the tangent line and the line AE are perpendicular to one another. They are perpendicular. So we know that when 2 lines are perpendicular, when you multiply their gradients together, what do you get? -1. So I can then put the gradient of AE as 0.25 and I can try to work out the tangent gradient. If you had to go work out the tangent gradient, you're going to get -1 over 0.25 and that's going to give you -4. So now we know what the tangent's gradient is. So therefore the gradient of the tangent is -4. So what is the equation of the tangent? Well, it's y equals to mx plus c. So we can say y equals to -4, because that's the gradient, plus c. We don't know what c is yet, but that's okay. That's fine for now. So what we're going to do now is we're going to make the parabola equation equal to the tangent's equation. So that's going to be x plus 4 times x minus 6, because that's the parabola, and you're going to make that equal to the tangent. Okay, then I just want you to get everything to the one side, so let's quickly go multiply all of this out. And then we're just going to put all the like terms together. Okay, now when I solve this equation, that is going to tell me all the different places where the tangent is touching the parabola. Why? Because I made them equal to each other. Remember that. I'm trying to see where is the parabola equal to the tangent. That's what we're trying to figure out here. Where is the tangent equal to the parabola? But I only want the answer. How many answers do we want, guys? Do we want the tangent and the parabola to touch each other 0 times, once, or twice? Like, do you want it to touch in 0 places, 1 place, or 2 places? Well, because it's a tangent, you only want it to touch in 1 place over there. Just once, okay? So, as we said, we only want the tangent to touch the parabola once. So we only want this equation, when we solve it, we would only want it to have one answer. So you might be thinking, okay, Kevin, I understand, but how do we make it so that it only has one answer? Well, this is where we come back to nature of roots. Why? Because if we can make this the discriminant, or the b squared minus 4ac, if we can make that equal to 0, then what we used to call that was equal roots. Equal roots. Now, what does equal roots mean again? It means like maybe your answers will be x equals to 3 or x equals to 3. That is what we mean when we say equal roots. So can you see that that actually means that there's only one place? Haha! So what we're going to do is we're going to go find the discriminant of this thing over here. Remember, your discriminant is the b squared minus 4ac, and we want that to be equal to 0, because that is meaning one root, or only one type of root. Okay? So your b value is going to be a 2. So we'll say 2 squared. Now a is 1. Now be careful, c is not this c. That's just a coincidence. C is all of this. Okay, so we're going to say minus 24 minus c, and you're going to make that equal to 0. So this is going to allow us to find c. So I'm going to solve it here. So we're going to say 4 minus 4, and then in brackets we still have this. So then I'm going to multiply the 4 in, so that's going to become 96, 24, 48, yeah, 96, and then plus 4c. There we go. Now, if you had to go calculate c, you should eventually get minus 25. So that means that that tangent is going through the y-intercept, or it's got a y-intercept at minus 25. Okay, so that's really nice, because now we know the value of c for that tangent. So this isn't the answer, but we close now. So now we can say that the tangent is y equals to minus 4x minus 25. Now that we know that, now we can just make the two equations equal, and it will tell us exactly where the two graphs cut. So we can make the parabola and the tangent equal to each other now, because now we have the tangent equation. We didn't have the tangent equation earlier because we didn't have its c value. Now we do. So I'm just going to quickly multiply this parabola out again, like that. And then I'm going to take everything to the left-hand side, and that's going to give us plus 1. Yeah, this is beautiful. Because now if you had to go factorize this, check this out. You're going to end up with x plus 1 and x plus 1. Haha. So we're going to get one answer. X equals to negative 1. So it means that the tangent is only touching the graph at minus 1. And then to find the y value, because that t is on both, you can plug that y value into the tangent's equation or into the parabola. It doesn't really matter. I'm going to use the tangent, and so I'm going to plug the x value of minus 1 into that, and this would give us minus 21. So the y value here is minus 21. So the final answer is negative 1 and negative 21. Now, for the grade 12 learners, okay, this is for the grade 12 learners now. If you're a grade 11 learner, trust me, you don't need to know this part. So you can just click, 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 and fast forward until you are onto the next question, which I think would be, 7.5. Okay, so you can just go ahead now. Trust me, This is not going to be helpful for you. Even if you're a student who does AP maths and you're like, yeah, no, but I know this, like I can do grade 12 maths. Trust me, it's a waste of your time. If I was you, I would just go to 7.5. All right. Look, if you feel like you need a bit of a break and you need to procrastinate a bit and you're interested to see how we do it in grade 12, by all means, I'll welcome you. So, but if you're pushed for time, you can go ahead. Okay, so for the grade 12 learners, it's actually going to be a little bit easier because we know about tangents in the section of calculus. So we know from grade 12 calculus that or grade 11 AP learners like, calculus, like easy stuff. So I didn't do AP maths, by the way, guys. I've got some AP maths learners that I've helped now, but when I was in school, I matriculated in 2011, so we didn't actually have AP maths back then. We had Cambridge maths, but I didn't do that either. I just did normal pure maths. So, but the AP maths stuff, it's pretty crazy. It's quite challenging. I did study engineering, so I did do a lot of that type of maths in my engineering degree, but yeah. I don't know where my story is actually going right now. So I think we should carry on. So for grade 12, you guys know that the gradient of a tangent is always the same as the gradient of the graph. You know, at the point where they contact each other. So let's actually scratch this out because let's pretend we don't know what that answer is. So at this point of contact, we should remember that the gradient of the tangent is the same as the gradient of the graph. And how do we get the gradient of a graph? Well, in grade 12, we now use calculus, and we know that that's from the first derivative. That's what gradient means. So to find the gradient of a parabola, you take the first derivative. Now, from the grade 11 approach, we already worked out what the tangent's gradient is, but maybe you didn't watch that. Maybe you jumped straight to the grade 12 method, because you ain't got no time for that. So maybe I need to show you how we get the gradient of the tangent once more. So that's pretty easy. So we know that when two lines are perpendicular or at 90 degrees, which they told us here, then we know that when you multiply their two gradients, so if you multiply the gradient of AE multiplied by the gradient of the tangent, then you get -1 because that's perpendicular, right? So the gradient of AE is 0.25, and the gradient of the tangent is the one that we're trying to calculate quickly. So if you had to go work out the gradient of the tangent here, you would get -4. Okay, so we have the gradient of the tangent, which is fantastic. So we can say -4 over there. Now we need to take the first derivative of f. So let's first multiply this out quickly just to get it looking nice. That would eventually give us this. Okay. So to take the first derivative, whoa, what happened there? To take the first derivative, we have to take the first derivative. I don't know what I'm trying to say there. So that becomes 2x minus 2. So I'm going to put here 2x minus 2. Okay, see how easy this is. It's much better than the grade 11 approach. Okay, so now we're just going to go solve this equation, and so we're going to end up with 2x equals -2, and so x equals -1. So that means that this contact point over here, the x value is -1. Now to find the y value, you can simply plug that x value into the original parabola equation because we know what its equation is, and that'll give us the y value. So we can just go plug in that -1 into the original equation, and if you had to go do that, that would give you -21. And so we can fill that in here, -1 and -21. So there we go. I've showed you the grade 11 method and the grade 12 method. Let's move on. So here's this one. It says that a straight line, which is G, which is parallel to AE. Okay, so parallel to AE is like that, or that, or that, or that, or that. You know, that's what parallel is. And it says that it cuts the graph F at -3, -9. So let's try to predict where that is. -3, -9. Maybe you want to pause, but that's somewhere here, right? -3, minus 9. So it's a line that's parallel, so it's going something like that. So this would be, it says it touches it at k, which is minus 3, minus 9. And then it cuts it again at r. So this would be r. That would be r over there. Okay, so this is not a difficult question at all. The reason is if we can work out the equation of this line, then we can simply make that equation of this line equal to the parabola, and it will tell us where what these 2 points are. So let's go work out the equation of kr. So our goal, you don't have to write this in the test, but our goal is to find equation of kr. Okay, now we know that it's a straight line, so that's y equals to mx plus c. We already know its gradient. Remember, the gradient of AE was, from an earlier question, we said 0,25. So the gradient of kr is equal to 0,25. Why? Because kr is parallel to AE. We know that. They've told us that. So therefore we can say y equals to 0,25x plus c. Now to find c, we have to plug in a point on this line. But that's okay, because we have the coordinates of k. So we can just plug in minus 9, minus 3, and then we can go calculate the value of c. And if you do that, you would find out that c is minus 8.25. So therefore, the equation of kr would be y equals to 0,25x minus 8,25. Now we know the equation of this line, so we can simply make it equal to the parabola, and that'll tell us k and r. We already have k, but that's okay. Haha. So let's go do that. We're going to make the two equations equal to each other now. So we can say 0,25x minus 8,25, and we can make that equal to the parabola's equation. I'm just going to multiply the parabola's equation out for the 74th time in this question. There we go. And now we can simply do our thing. So we can move everything to the one side. You guys know all of this by now. Okay, and then we can put everything together. Definitely going to use the quadratic formula here, hey guys. So this is minus 15.75. Okay, so now we are going to use the quadratic formula, this one. Now some learners always ask me, should I plug in the values? Do the teachers want to see that? And the answer is yes, show them that. So the minus b, so there's a minus there, and then the minus is, the b is also minus, so I show it like that. Then you can just say plus minus, and then you're going to put the thing in brackets here. Must be in brackets, very important there. Just put everything in brackets actually. Brackets will never make it wrong. Minus 15.75 over 2 times a is 1. Now we're hoping that one of our answers is minus 3. Because we know that they do cut each other at minus 3, but we want the other one. So if we don't get minus 3, we know that something's gone a bit funky. Okay? So if you had to go plug this in on your calculator, the two answers that you should get will be minus 3, haha, so we know it's correct. And then the other one is 21 over 4 or 5.25. And they just want the x coordinate of r. So we don't have to go find the y value, and so that is the answer, 5.25. So in the test, you would say, you'd put a little line through that one, because you're just telling the teacher that it's not that one. A farmer bought a tractor for 980,000 Rand. The value of the tractor depreciates annually at a rate of 9.2% per annum on a reducing balance method. Calculate the book value of the tractor after 7 years. So there are grade 11 and 12 learners watching this right now, guaranteed. For the grade 12 learners, what happens to a lot of you is you move on to grade 12, you start doing grade 12 financial maths, and suddenly you think that every question on financial maths is a grade 12 question. So some of you grade 12 learners right now, you're like, okay, is this a present value or is this a future value question? But it's none of those. This is actually a grade 11 question. and you need to know the difference between the two, okay? So a grade 12 question is when someone is putting money into an account on a monthly basis, for example, like 500 Rand, 500 Rand, 500 Rand, 500 Rand. It's called an annuity, but this is just a normal grade 11 question. Okay, so look out for that. So they're telling us that this person's tractor is going to become less, so it's going to depreciate. Now, there are two ways that things can become less. You use a minus like that, or you use a minus like this. This one is called straight line depreciation, and that looks like this. It's literally the value of the item decreases in a straight line. Let's make that a bit better, like that. Then you get something called the reducing balance, and this is when something gets less, like that. Okay, and they've asked us to use the reducing balance method. Most of the time in grade 11 and 12, that is the way it will be. So we are going to use this one. It's the same compound formula that we've always used, but instead of a plus, you've got a minus. Okay. And just a little refresher in case you're doing revision. A is the final, P is the start, I is the percentage or the interest rate, and N is the time, for example, like the years or the months. Okay, so let's go write down our formula. So the final amount is what we're trying to work out. The starting amount of this tractor was 980,000 Rand. The interest rate is 9.2, and it's annually. Most of the time when we're busy with depreciation and inflation, we just use annually. We don't use monthly, quarterly, things like that. You might get a question like that, but I've never seen it, okay? It's usually, if they don't mention anything, it's just annually, and here they are saying per annum, here they're saying annually, so it's pretty obvious, eh? So you can say 9.2 over 100, you could say 9.2, and you can type in the percentage symbol in your calculator, but what I like to do is I just divide it by 100, and then I just put it into the formula like that, and then after 7 years. And then we're just going to go plug this all in, and there we go. It is now worth 498,685.82. How many years will it take for an amount of money to get to that if we have quarterly interest rate? Now, there are definitely grade 11s and 12s watching this question, and for the grade 12 learners, please don't be or get into the habit of always thinking that your financial maths questions are either grade 12 or they're only grade 12. So don't always think, oh, is this a present value question or is this a future value question? It's none of those. Remember, you need to be able to identify whether we are busy with a grade 12 question or a grade 11 question. A grade 12 question is one where we have an annuity, where someone is putting money into an account on a regular basis, like 500 Rand every single month, or something like that. Okay, this is just a grade 11 question. So it says, how many years would it take for this amount of money to become this amount of money in compounding quarterly? So it's just a normal compound interest formula from grade 11, so we just use that. Remember, A is the final, P is the start, I is the percentage, and N is the time. Let's just say time. Okay, so we know that the final amount is that, so we can say 116,253,50. 116,253,50. The starting amount is 75,000. The interest rate, now here's where you got to look out. So it's 6.8% per annum. So I like to say 0.068, but you could say 6.8%, or you could say 6.8 over 100. And then quarterly, there are 4 quarters in a year. And now we are going to say, normally you would multiply this one by how many years there are. So let's say it was 5 years. Then you would say 4 times 5. But we don't know how many years that there are, so we're just going to say 4 times n, where n is the number of years. So n equals the number of years. Some learners just like to put n over here. They just put n over there. But then at the end, you're going to have to divide your answer by 4. But I'm just going to do that. Okay. Or let me actually just say 4x, for example, where x is the number of years. So you got to understand what you're doing here. Okay, so x is my years, but if you just said x, then at the end, then x for you wouldn't be years, it would be quarters. It would be number of quarters. Okay, so I'm not going to speak anymore. I feel like I might be confusing some people. I apologize. So I'm just going to call that, so if I write it like this, then x is my number of years. Okay, you might have just think about what I'm saying there. Right, now what I'm going to do is I want to eventually get this by itself. So we're going to say 116,253,50 divided by 75,000, and that's going to be equal to, I'm just going to keep this as it is for now. Okay, and then to the power of 4x. Now, this is actually going to be an area where we're going to need to use logs. So this is actually strictly a grade 12 question. So we're going to use logs now. So the way logs works is we're trying to get this by itself. So I'm going to say 4x. Then you're going to say log, and then you're going to put this part first. You could go write it all out, but you don't want to round off at all. So I'm just going to keep it like this. And then I'm going to put 116,253,50 over 75,000. And then I'm going to go type that all into my calculator. And that gives us 4x equals to 26. It literally rounds off, but let's not round off right now. Let's keep it for a bit because that's not our final answer. Okay, I'm going to keep it like that. And then I'm just going to divide whatever answer I got on my calculator by 4. So I'm going to divide that by 4. And if you round off, you're going to end up with 6,50. So that is the number of years, therefore 6.50 years. Here we have a financial maths question. So we are told that Tabo wanted to save 450,000 Rand as a deposit to buy a house on 30 June 2018. He deposits a fixed amount of money at the end of each month. Okay, so this is definitely a grade 12 question. Now, I'm going to break every question up into individual questions on each slide just to keep it neater and to give us more space to work. They tell us that he deposits a fixed amount of money at the end of every month into an account earning interest rate. Okay, so we've got our interest rate there. His first deposit is made on 31 July and his 60th deposit on 30 June. Calculate the amount he deposited monthly. Okay, so some learners, they read these numbers and they think, I think they're trying to trick me here. And I can tell you that in 85 to 90% of the time, they're not trying to trick you. What you must remember though with grade 12 future value, present value is the following. If the person is compounding monthly, okay, then the first payment must always take place after 1 month. Sometimes it doesn't, but then we need to make a little modification. But this is the way it should work normally. So the first payment must always be made after 1 month, and the last payment should always be made right at the end, at the very end, at the very end. Okay, so let's see if that person does this. So this person opens the account on 30 June. Okay, so when should the first payment be done? Well, it should be done in a month from then. So yeah, you might say, yeah, but isn't that 30 July then? But it's because June has 30 days. Okay, so June has 30 days and then July has 31. So they're doing it at the end of the month. So this person has taken a whole month. That's perfect. So they did that one. And then sorry, he didn't open the account on 30 June. He would have opened the account on 30 June 2013. We can assume that, and then he makes his first payment on the 31st of July, which would be the 1 month later. So this is the perfect scenario. And then he makes his last payment on 30 June 2018. So he makes the last payment right at the end. So there's nothing funny about this question. Right, now to work out the number of payments, because it's just the normal scenario, from 2013, to 2018, that's 5 years, and he's compounding monthly. So his number of payments would just be 5 times 12. You don't need to minus anything, you don't need to plus anything, because this person is following the normal standard approach. They're not trying to catch us out at all over here. So, okay, now we need to decide if it's a future value or a present value question. So Tabo wanted to save he wants to have 450,000 Rand in 2018, but when did he open his account? He opened his account on 2013. So when he opened his account in 2013, was he saving? Was he wanting the money for the future, or did he want the money immediately? No. Well, I can't say no, that doesn't make sense. But he opened his account in 2013, but he only wanted the money in 2018. So he only wanted the money in the future. Okay? So it's definitely a future value question. So we can write our future value formula down. Alright. Now everything's pretty standard. How much money did he want? He wanted 450,000 Rand, so that's the future value. We don't know how much he paid every month. That's what we're trying to calculate. The interest rate was 8.35%. So I like to divide it by 100 automatically. Then I divide that by 12 because they said compounded monthly. The number of payments is just 5 times 12. Well, we can be technical here and say 5 times 12. Minus 1 over 0.0835 over 12. Everything's standard in this question. They did not try to trick us. Now to get x alone, I like to do it all in one step. So I'm going to go like this. So I'm going to say 450,000. Then I'm going to multiply that by this. So what I did is I took that over, or divide by. And then I'm just going to divide by all of this. See, I don't touch my calculator for now. There we go. And then I would go type it in my calculator just like that. And if we do that, we get a value of x4 as 6,068 Rand and 69 cents. Now here's the next part. So it says that Tabo bought a house. Now some of you reading this, you're like, okay, now what the heck is going on? Is this dude buying a house for 450,000 or is the house 1.5 million? Guys, the house itself is this much. But sometimes when you buy a house in real life, the bank asks you for a deposit. A deposit is like an amount of money that you give them in the very beginning. It's like a bit of a safety thing for the banks. They don't want to give you all the money for the house. They want you to also give a little bit. It's more safe for them. Okay? So this part here is just the deposit. That's not the total value of the house. The total value of the house is this much. But he's going to use his savings as the deposit. So on the day when Tabo buys the house, he's gonna ask the bank for the house is worth 1.5 million, but he's gonna give the bank 450,000 immediately. Okay, and the rest of the money, that is the loan. That is the money that the bank is gonna lend him. Okay, so it's like this: the house is worth 1.5 million. Tabo is going to pay off 450,000 Rand of that. So how much money does he actually need from the bank? Well, if you minus those two values, then the amount that the bank is going to lend Tabo would be 1,050,000. That's how much the loan is actually going to be. He's already paid off the 450,000. I hope that makes sense. So this is the total value of house. This was his deposit. And so the leftover amount is how much he is for the loan. So he obtains a home loan for the balance. You see there the balance, that's this amount. And the bank gives him an interest rate over 25 years. So he's going to pay his house back to the bank over 25 years. That's pretty normal. Sometimes people get a 30-year loan in real life. Sometimes it's a 20-year loan. He made his first monthly payment on 31 July. Okay, so everything's pretty standard over here. Okay, there's nothing funny. Now it says, what is the outstanding balance? Now, if you watch some of my lessons, you know that there are two ways to calculate outstanding balance. Okay, OB for short. There is a present value method, and there is a future value method. So, in the present value method, you're literally just going to use the present value formula. Okay? But what you must remember is that this n, when you're using the present value method, is, let's just say, still need to make. Okay, then there's the future value method, with which other types of learners enjoy this one. You don't have to do both, hey? Some learners ask me, must we do both? No, you just do one, and you will not always get the exact same answer, but it'll always be like one or two, or like a couple of cents off, like maybe 15 cents or 20 cents. It'll always be quite close. Okay, you'll see on the memos the answers aren't the same for both methods every time. Okay, for the for the future value method, you're going to use this formula now. So you're going to use like the grade 11 compound formula, and then you're going to minus that with the grade 12 future value formula. Okay, so can you see that? This is that grade 11 formula that goes like this. And then this is your future value formula. You know, f equals 2. That's that one over there. So this is the other approach. But now when you use this one, then the n that you use is the number of payments that you have already made. Already made. That's the only difference between the two. Got it? So you can choose whichever method you prefer. So you see, for 3 marks, they're really not trying to catch us out here. So we know that he's been paying for 21 years. Okay, so how many years did he do this thing in total? 25 years. So if we use this method, then how many years does he still need to go? He still needs to go another 4 years. That doesn't mean you're going to put a 4 here. That means you're going to put a 4 times 12. So this would be 4 times 12. Okay, if you use this one, then you look at how many years you've already gone. So how many years have you gone? 21 years. So then this n would be 21 times 12. But besides that, it doesn't matter which one you want to choose. So eeny, meeny, miny, mo, I'm going to go with the one on the left. It's a little bit easier, not as much work. And remember, this p is from your grade 11 formula. So it's like the starting amount of the loan. Now actually, should I maybe do that one? Actually, let me do both. So with the present value method, okay, so what we're going to do is we're going to say the outstanding balance is equal to, now for the loan, they gave him a 11, I nearly used the 6,000 Rand value that we worked out earlier, but in that question, this one here, that was some other type of account that he opened. That's just because he was trying to save up money. So that was a different investment. Okay, so for this one, there's a different value now that we're using. That's his monthly installment. So we're going to say 11058.85. And the interest rate for this compounding one is 12%. Now remember, we said that for this one, it's the amount of payments that you still need to make. I don't know why I erased that. Still need to make. And then for these ends, it's payments already made. Payments already made. Okay, so the amount of money we still need to make, we said that was 4 years. Remember, I said that just now. So that's 4 times 12. So we can say 4 times 12, but it's a negative. Okay, over 0.12 over 12. Go ahead, type this all in. And we get 419948.32. 419948.32. Okay, now we're going to look at the future value method. So if you are a student that doesn't like to use the future value method, then you do not need to watch this next part. It's not necessary that you have to be able to show both. Okay, you only need to know one of them. So let me now do the future value method. So in the future value method, this P is the loan amount. It's not the total, it's not the deposit, it's the loan amount. So that's going to be the 105 value, okay? The interest rate, I think I'm going to run out of space. Give me a second, please, guys. Okay, so I'm going to use the future value over here. So the outstanding balance then would, so the loan amount was the 105 value, and then the interest rate was 12%, and then this is the payments that have already been made, which is 21 years. So that's going to be 21 times 12. Then you're going to say minus. Now the monthly payment is 11,058.85, and the interest rate is 12%. And this stays 21 times 12 minus 1 over 0.12 over 12. Then you go ahead and you type all of that in on the calculator. Might take a bit of time. And then we hope and pray that we get the same answer as we got earlier. Ha! We did. Okay, and as I said, it's not going to be exact. It's going to be a few cents off. And that's even like that on the memos. 419,952.39. Whereas for the present value method, we got 419,9. Oh, it was a few rand off. Okay, that does happen too. I wouldn't expect that though. 9, but it's like literally like 4 rand, guys. It's not bad, hey? Okay, so that's what we got in the present value, and this is what we got in the future value. But on the formula sheets, they make allowance for that. And I've just gone to go check on the memo now, and it's exactly the same. So the present value formula, we got the right answer, and the future value, we also got the right answer. So that does happen. Okay, you get different values. Right. With this next question, some learners find it a bit weird, but it's actually quite easy, and I'm going to do my best to just try to show you how it works. So what I want us to start off with is the following. So let's see, Tabo, let's see what his loan was worth in the very beginning. Okay, so in the beginning, how much was the loan worth? Well, the loan was worth that much. So that's how much money he still owed the bank. Okay. Then Tabo has been paying his loan off for how long? 21 years so far. That's how long he's been paying it for. And how much money does he still owe the bank? What is the loan? Well, did you know that that's what the balance outstanding is? The balance outstanding is how much he still owes on the loan. And we worked that out. Now, obviously, some people used the present value formula, and some people used the future value formula. So I'll have to do both. So for the I don't want to confuse people. Okay, so if you use the present value, then the present value method, then you would have his loan. Let me actually make this a bit smaller. His loan is still worth 419948.32. If you use the future value method, then it was 419952.39. Okay, so that's how much the loan is still worth. Okay, so have a look at this, guys. His loan was worth 1,050,000 rand. That's how much money he owes the bank. That's what a loan is. It's how much you owe the bank. 21 years later, this is how much he still owes the bank. Now, let's see how much money Tabo has actually paid back to the bank. Let's see how much he's actually paid back. So how much has he paid the bank? Okay, so we know that he paid this amount of money every single month. So we times up by 12 to see how much he pays per year, and he did that for 21 years. So let's see how much money this guy has paid the bank. Okay, so he's paid the bank over 2 million rand. Some of you are like, Kevin, why would he pay back the bank more than, why would he pay over 2 million rand when the loan's only that amount? Guys, when the bank gives you money, they make you pay back a lot more. That is because of interest. That's the interest. Alright, so this is how much money Tabo has paid. So look at this, guys. Think about this carefully. Tabo has paid the bank 2.7 million rand already, but his loan amount has only gone down from 1,150,000, and it's gone down to that much. So how much has the loan decreased by? Well, let's see. Loan decreased. Well, that would be the original loan amount minus what it is now. So either present value. Sorry, I'm not combining values here. So I'm going to have to use the future value method or present value. So if you use the present value and if you use the future value. Okay, so if you use the present value, then that's going to be And that's going to give us... Okay guys, I'm actually just going to do it using the present value method only because I'm running out of space like completely here. So I'm just going to use the present value method, but you can follow along with the future value as well. I mean, it will be the exact same thing, okay? So let's see how much the loan decreased by. So the loan decrease would be the 105 minus 419948.32. And that's going to be equal to 630,051.68. So think about this very carefully. Thabo has paid the bank 2.7 million, over 2.7 million back, but his loan has only gone down by 630,000 rand. So where did his money go? Like he's giving the bank 2.7 million rand. And the person at the bank says, oh, but your loan has only gone down by 630,000 rand. Imagine that, guys. You pay the bank 2.7 million, but they tell you, oh, your loan has only gone down by 630,000. So where did all of his other money go? Is someone at the bank stealing it? No, that is interest. So not all of the money that he pays back to the bank gets used to take the loan down. Some of it is being used as just the interest, you see? So he paid 2.7 million back to the bank, but only 630,000 rand was actually used to lower the interest. I mean, to lower the loan. The rest of the money is interest. How crazy is that? So the amount of interest that Thabo has used, it's almost like that money just disappeared. But that's what the interest is. It just disappears. Is going to be 2786830.20 minus 630051.68. And that gives us 2156778.52. If you use the future value method, your answer will be a little bit different. If you use the future value, so if you used the future value, then your answer would be, okay, so if you use the future value, you should get 2156782.59. 2156782.59. In this question, we have to determine the first derivative using first principles. Now, you are always going to get a first principle question in any exam that has calculus in it. I can guarantee you that. And it's always going to be worth about 5-6 marks. And it's a very easy process. So what I mean by that is once you understand how these questions work, they can only ask it in so many different ways. They can't really trick you, okay? So we know that the formula for this goes like this. You say f of x, or first derivative actually, equals to the limits as h goes to 0, and then it's this formula. Okay, now I do find that some learners, they do struggle with this part over here. They don't really know what it means. So let me try to explain. If I ask you what is f of 1, well, most of you would be okay and you would understand that that means that you're going to replace all of the x's with with 1. So it would look like this, right? But then what if I asked you what is f of x plus h? Well, what that means is that you're going to replace all of the x's with x plus h. So it looks like this. See what I did there? I replaced all of the x's with x plus h. That is what this part is over here. Okay? So now if we go and actually fill this in, unfortunately we always have to write limit as h goes to 0. Teachers or the curriculums, they're pretty weird about that. Like if you don't, they will minus marks. So you have to do that the whole time. And now we're going to go fill it into here. Okay, so let's start with the first part, which is the x plus h. So we're going to go 2 x plus h squared minus 3 x plus h. Okay, so that's this part. Then there's a minus, so I put a minus. Then I open up a bracket, and then they want f of x. So what is f of x? Well, that's an easy one. F of x is literally just that. So I go 2x squared minus 3x. Now, that's the difficult part, by the way. If you can get that part right, then usually it's okay. Remember to put a bracket here. That's very important. Now, in the next step, we are going to go and simplify. Okay, so what a lot of learners do incorrectly here is they do the following. They say that x plus h squared, and let me just say here that this is incorrect. They then say that this is x squared plus h squared. But guys, what you got to remember is that if you have x plus h squared, it actually means x plus h and another x plus h, and then you multiply those two brackets out together. Okay, so I'm going to do that for us now. So what we have is a 2, and then I'm going to multiply those two brackets out, which would eventually give us the following. Then I'm going to put the minus 3 in, and then I'm going to multiply this minus into this bracket. Then the last step, I'm just going to put the 2 into the bracket, and there we have that now. What you're going to do in this next step is just simplify and cancel things out. So for example, this 2x squared would cancel with that 2x squared, and this minus 3x would cancel with this 3x. Grade 12s, listen up carefully now. I always find it weird when I say grade 12s. I feel like a real teacher when I do that. Graad 12s. Sorry, that was terrible, Kevin. I don't know where that came from. But I'm not Afrikaans, by the way. I just find it funny the way Afrikaans teachers say that. I'm English, if you didn't know. So, what happens now is that everything, listen carefully, so everything that didn't have an h must cancel. So can you see this one didn't have an h, this one didn't have an h, this one didn't have an h, and this one didn't have an h. That must always happen that way, okay? They must cancel out completely. All the things that don't have an h must cancel. If that doesn't happen, it's usually because you haven't used a bracket over here, for example, okay? So if that does happen, just rewind a bit with your work and just try it again, because it must cancel. Everything without an h must cancel. So what we have left is 4xh plus 2h squared minus 3h. You see now, what we can now do is each of these terms has an h in it. So now we can take out a common factor, but we wouldn't have been able to take out a common factor if one of these was still remaining. You see what I'm saying, guys? So now we're going to take out an h. Please don't mind me, but I'm going to have to write over here just for space. Just trying to save paper as well. So we take out an h over here. Oh, I should always say, I made the big mistake. Limit as h goes to 0. Going to be giving teachers heart attacks here. So silly, hey guys. So anyways, so we take out an h, and then it's going to be 4x plus 2h minus 3 over h. What then happens is that these cancel. So I'm just going to write again, so 4x plus 2h minus 3. Now we are in a position to let the h become 0. So in the next step, you don't have to say limit as h goes to 0, because now we're going to let the limit or the h become 0. So you show them that it's becoming 0 like that, and then you just write out your answer as 4x minus 3. So the final answer is 4x take away 3. In this question, they are asking us to determine dy over dx. Now, there are 3 different ways that they can ask this question. They can say dy over dx. They can say f of x, or they can say this weird thing here, and then they use like these square brackets, and then they put the expression inside there, for example. All 3 of those are actually just saying the first derivative. Okay, so here they're saying dy by dx, so we're going to say, so don't do this now, don't say f of x equals, because then you're not sticking to the notation. They won't penalize you severely, you might lose a mark. Okay, so we're going to go dy over dx, and then we're just going to do the normal derivative. So you're going to take the 5 and multiply it to the front. Some of you are like, Kevin, why didn't we use first principles? Guys, you only use first principles when they ask you to use first principles. Okay, like in like in some of those questions we've done, they'll say using first principles. Okay, now we're going to take this 4 and we're going to multiply it to the front. So that's going to be 24x to the power of 3. and then this just becomes plus 3. This question is asking us to determine the first derivative. Now there are 3 other ways that they could ask that, or 3 different ways including this one. So they could use the dx method where they use the square brackets, which is what we have here. Then they could say f of x, like that, or they can say dy over dx. Those are 3 different ways that they can ask you to find the first derivative. So the way that this one works is you're just going to say equals dx. Now we can't take the first derivative just yet. We need to clean this up quite a bit. For example, you never want to have any x's in your denominator, and you never want to have square roots or cube roots or any type of root. So let's get rid of those things. So this x at the bottom here, or this x there, sorry, needs to eventually come to the top, and this needs to be taken out of a root form. Okay, so how do we do that? Well, if you have a root, and this is a a and this is a b, we should remember that this is the same as x to the power of a over b. Okay, so if there is a 1 over here, then this is going to become x to the 1 over 3 over 2, and then this part here is the same as 1 over 3x. I'm not going to take the x up yet, times 1 over 3x. That becomes 1 over 9x squared. Now, in the next step, I'm going to take that x to the top, but I'm going to do a few other things as well. This 2 over here, we can imagine that there's a 1 in the front. So we can put the minus half, in the front, like that. And then say x to the third. I'm not taking the derivative yet. Then for this one, I can say 1 over 9, and then I can bring the x to the top. So we can say x to the minus 2. See, I took the x to the top, so it became x to the minus 2. Now I can take the derivative, and so now I don't say equals to dx again, because now I'm going to take the derivative, and so now I do the normal thing where I multiply this to the front. So that becomes minus 1 over 6x, and then you minus 1 from here, so that becomes minus 2 over 3. And then I do the same with this one, so it becomes minus 2 over 9, because I multiplied this over here. And then x to the power of minus 3, because I minused 1. Now, listen up carefully, guys. Sometimes in the IEB curriculum, they let you leave the answers with negative exponents like this. But for those of you in the CAPS curriculum, which most of you watching this are actually in the CAPS curriculum, we don't leave the answer with negative exponents. So what we do is we take this down to the bottom, and we take this down to the bottom. So what that ends up becoming is the following. Minus 1 over 6x to the power of 2 over 3 minus 2 over 9 x to the power of 3. In this question, we have been given a graph of h of x equals to ax3 plus bx squared. And then it says that the graph has a turning point at the origin and at point B, and A is an x-intercept. So it says for 5 marks, show that A is minus 1 and B is 6. Alright, so the first thing I know is that this 4 and 32 is a point on the graph. So I can just go plug that into the equation. So I can say 32 is equal to A, and then 4 to the power of 3 plus B times 4 to the power of 2, and I'm just going to neaten that up a bit. That's going to give us 64a plus 16b. I'm going to divide everything by 16. You don't have to, but it just makes the numbers a bit better to work with. Sorry, by 16, so that would become a 1. My bad. Okay, so there's our first equation. The next thing I know is that this is also a turning point. Now, how do I normally find a turning point on a cubic graph? Well, to find a turning point, I normally make the first derivative equal to 0, right? That's how I find turning points or stationary points. So I'm going to take the first derivative of this function, which would give me 3ax squared. See, because I just multiplied this 3 to the front, plus 2bx. Okay, and I know that I make that equal to 0, and I know that the x value at that point is a 4. Some students, they would put a 32, but we can't put a 32 here because this 32 is a y value. This isn't a y value. This is your first derivative. It stands for the gradient. Okay, and then we've got that, and we've got that. Okay, and then we've got 16 times 3 is 48a plus 8b. We can divide everything by 8, and so we're going to end up with 0 is equal to 6a plus b. And so here we've got two beautiful equations that we could now solve simultaneously. Now, there are multiple ways to solve simultaneously, so you might not do it the way that I do it, okay? So what I would do is, I know what most students prefer. They get the b by itself. I'm just going to get b alone over there. Now, you can get this b alone as well if you wanted to. There's nothing wrong with that. But what I'm going to do is I'm going to take this expression now, and I'm going to plug it into here. I'm going to replace it like that. So we're going to end up with 0 is equal to 6a plus 2 minus 4a, and then we're going to end up with 0 is equal to 2a plus 2, and if you had to solve this, you would eventually find out that a is equal to minus 1. Okay, then to find b, you just plug it back into this equation, for example, and we'd find out that b is equal to 6. Okay, so a is minus 1 and b is equal to 6. So now we have the equation. Whoops, it's right, it is h of x equals to minus 1x cubed plus 6x squared. Okay, so we have that equation now, which is fantastic. Now the next question says calculate the coordinates of a. So the coordinates of a, that's just the, that's an x-intercept. So we would make our y equal to 0. Now we could take out a common factor here of x to the power of 2, and then you'd be left with minus x plus 6, and therefore you can say that x squared is equal to 0, or x is equal to 6, or if you want we can first say minus x plus 6 is equal to 0, and so what we'll find is that x is equal to 0, but there's two of these, can you see there? Because it's x squared, so it's two answers, and that's why we're getting a turning point there. So when you get a turning point, which is also an x-intercept, it means that there are two of them. So just remember that for future types of questions. And then, or x is equal to 6. Okay, so the coordinates of a would then be 6 and 0, because the y value is obviously 0, because it's the x-intercept. Here it says, write down the values of x for which the graph is increasing. Okay, so we know that increasing would be here. That's where the graph is increasing. Yes, you could use the equation as well to help you do that. We know that an increasing graph is where the gradient is positive, so you could say something like that. But guys, it's only for 2 marks. So we can just look on the graph and we can just say that x is bigger than, no, not equal to actually, because it's not increasing at 0, and then smaller than 4. Your other option is that you could use interval notation, so you could say this. Whoopsie, Kevin, what are you doing, buddy? From 0 up to 4. And then the next one says, where is the graph concave down? Okay, so concave down is when the graph looks sad. So it's like this. So it's this area here. That's the concave down part. But we don't know what this point is. We don't know what its coordinates are, but we do know that that's the point of inflection. And to find that point of inflection, you make the second derivative equal to 0. That's how you find an inflection x value. Okay, so we need to go find that quickly. So we're going to have the first derivative, the original equation, which is this. Then we're going to take the first derivative. And then we're going to take the second derivative. And then we're going to, that's a plus 12. And then we're going to make that equal to 0. And then if you had to go solve that, you would find out that x is equal to 2. So the x value over here is a 2. Okay, the x value there is a 2. We don't need the y value. They haven't asked us for that, so we just know that the x value is 2. So it says write down the values of x for where the graph is concave down. So it's all of this. So you could just say that x is greater than 2. The next one, for which values of k, everyone's favorite, that's a joke guys, for which values of k will this graph, will this thing have 1 negative and 2 distinct positive roots? I want to show you guys something. I want to quickly write out the original equation. Okay, so that was the original equation. Now look what they've done here. So And then I'm just going to take this k to the other side. Okay, so can you see there is a bit of a similarity with these two expressions? What they've done is all of the x's, can you see that all of the x's have been replaced with x minus 1. So what does x minus 1 do? If you replace all the x's with x minus 1, you are going to move the graph one place to the right. Some of you are like, Kevin, dude, it's to the left because it's minus. But remember, guys, from grade 11 already, we know that when it's an x value, it's the opposite. Okay, like in a hyperbola, sorry. If you have an x minus 1 at the bottom, it moves the graph right. Okay, so what they've done is they've moved this graph that we already had one place to the right. So to get an idea, it would look something like this. So all of these points are going to move one place to the right. Okay, so you're going to get something like this now. Okay, so that's sort of what our graph is looking like now. And they said equal, and now we've made it equal to k. So remember, k is like your y value. Okay, now check this out. If k is 2, then your y value is 2. So I could that would be here, where your y value is 2. Okay. If k is minus 1, then that would be a y value of minus 1. So that would go somewhere there. So they want to know what y values will this graph have 1 negative and 2 distinct. Distinct means different positive roots. So let's just talk about this. Let me show you a few scenarios. Let's say, and we must remember that this coordinate here is 5 and 32. Okay, so let's say k is equal to 35. Let's say k is 35. So 35 would be a y value up at the top here, because it would be higher than this 32, right? So how many times would it cut the graph? Well, it would only cut the graph there at one place. So that would be 1 negative, y negative, because it's a negative x value. So you'd say 1 negative root. That's what roots mean, okay? Now, what if k is equal to 10? So k equals 10 is probably somewhere here. So how many times does it cut the graph now? Well, it cuts it here, here, and here. So if k was 10, now obviously I don't know exactly where it would have cut, I'm just using some examples, then we can say that we've got 1 negative root. Why? Because it's got a negative x value, and then 2 positive distinct roots. So it's also got 2 positive distinct roots, and that would be this one and this one. They're distinct because they're different. Maybe, and they're positive because they have positive x values. So maybe this one's x equals to, I don't know, 7, or let's be more realistic, 2, and maybe this one's x equals to 6. Okay, so those are just some examples on how you can understand this question. So it says, for which k will we have 1 negative and 2 positive roots? So we want 1 negative and 2 positive. Okay, so it won't be up here, because then we only get 1 negative. It won't be down here, because then you get 1 positive. But if we go and it won't be on this line, because then this root over here is not called distinct, because that would be like x equals to 1 and x equals to 1. So that's not distinct. So where we would want to go is in between the two turning points. Then you're going to get, well, actually, that's not true, because if we came over here, then you've got 3 negatives. Can you see that? Then they're all 3 negatives. So it has to be, you want to be above this y-intercept. Because as soon as I draw a line down here, then I'm cutting the graph 3 times, but they're all positive roots, but they want one of them to be negative. So it would have to be somewhere between this dot and this dot over here. So like, for example, if a line goes across there, then it's got 1 negative root and 2 distinct positive roots. See that? So k is going to be the y values that are between these 2 red dots. Okay? Between those 2 red dots. Now the problem is, we don't know what this y value is over here. So what we could do, maybe there's better ways, but we need to know what this point was before it moved, because then when you move it one place to the right, its y value would still stay the same, right? So we from the original graph, we knew that the x value here would be -1. Why do I say that? Because once you move it one place to the right, then its x value would become 0, which is this one. Okay, so let's go work out what the y value at that point was on this original graph. So by doing that, we'll plug in x is -1. And if we had to work this out, we get 7. Okay, so the y value here is 7. Then when they move the graph one place to the right, it's still going to be 7 because you're just moving it horizontally to 0 and 7. So this y value is 7. So we can then say that k can be anything between 7 and 32, because anywhere between that, the graph gets cut 3 times, where one of them is going to be a negative root, like this one, because it's got a negative x value, and the other 2 are going to have positive x values. And if you are someone that prefers interval notation, my bad, nearly forgot about you guys, you would say k is an element going from 7 up to 32, but we're not including any of those values. This is the type of question that you look at in an exam and you have like a heart attack. It looks crazy, right? But in this lesson, I'm going to show you that this question is actually pretty straightforward. It's quite easy. So check this out. After traveling a distance of 20 kilometers from home, okay, so let's look at that. That's important. That 20 is actually so important to us. So here's the person's home, and then they travel 20 kilometers. And this is where they are here now, or here. This is where they are now, so they're here now. After traveling a distance of 20 kilometers from home, a person remembers that he did not close the tap. He decides to turn around, and he's going to now drive back home. Okay, so he's going to drive his car back home to go close the tap. The cost of the water is going to cost him 1 Rand 60 for every hour that he takes. So it's going to cost him 1 Rand 60 per hour. So at home, his tap is busy running, and every hour that tap runs, it's going to cost him 1 Rand 60. His petrol is going to cost him this much per kilometer. But we know how far he's going to drive. He's going to drive 20 kilometers. So how much petrol would... Think about this carefully. This is how much he's going to spend on petrol per kilometer. So then how much is he going to spend on petrol if he drives 20 kilometers? Well, you would just multiply those two, right? So guys, have a look here. The total cost that this person is going to use up is going to be his petrol cost plus his water from the tap, which is from the tap. Okay, so the petrol cost, because we're trying to keep the cost as a minimum. So that's why I'm making a formula with cost. Because, whoopsie, whoa, what's going on here? Sorry guys, don't know what happened there. So it's like Stranger Things or something. So the cost needs to be a minimum. So I'm making a formula with cost. You always want to make a formula with the thing that they want you to find the minimum or the maximum. If they want the maximum volume, you find the volume. If they want the maximum area, you find the area. Okay, so the petrol cost is just going to be these two multiplied together, so that's pretty straightforward. Okay, then his water cost, well, it's 1 Rand 60 for every hour. So let's say 1 Rand 60 times by how many hours, which we don't know. So I'm just going to say H for hours. You might say, oh, Kevin, why didn't you use X? Because X is not time. X was given to us as speed. Okay, so we have a problem because now we have two variables. But we know that time, which is this h over here, we know that time is also distance over speed. So we know how long this guy's going to take to get back home because we know that he's going to travel 20 kilometers, that's his distance, and the speed is x. So we'll just change it to that. So this parameter here is just going to change to 20 over x. Pretty straightforward, hey? And so now we're just going to go simplify this expression. So I'm going to say C instead of saying cost. I'm pretty cool in that way. Like, I don't have time to write cost, so I just say C. It's pretty cool. Guys, I'm just messing around. So 20 times 1.2 is 24. Okay, so I'm just multiplying this 20 in right now and just trying to neaten everything up. And then the 20, this 20 is going to multiply at the top. Some students also ask me, does it also multiply at the bottom? No, it doesn't, because it's 20 over 1. So that's going to become 20x over 4,000. Then I'm going to multiply this now, only at the top. And so that's going to be 32 over x. Right, and then we're just going to simplify a little bit more. So that's going to become 24 plus x over 200 if you want, or you can say 1 over 200 x. That's this part simplified. And then we never want to have an x at the bottom when taking the first derivative, because we're going to take the first derivative just now, so we do that. So I brought that x to the top, and that's why it is now minus 1. Okay, now remember guys, to find a minimum, that's what they mean as low as possible. To find a minimum, a maximum, we're just using grade 12 calculus where we make the derivative equal to 0. Because to find a minimum or a maximum, this is where you make your first derivative equal to 0. So now we are taking the derivative of c with respect to x. So we're not going to go like this now. Where did the f come from? Where did the x come from? No. What we rather do is we say dc over dx. See that? We're taking the derivative of c with respect to x, like that. And that's going to give you, okay, so this 24 is going to fall away, because that's what happens when you take the derivative. This part here is just going to become 1 over 200. And this next part here is going to become negative 32x to the minus 2. And then we're going to make that equal to 0, because that's how you find minimums and maximums. So we're going to say 0. There we go. So now we're just going to solve this. So I'm going to take the 32x to the minus 2 to the left. I'm then going to put the x back at the bottom. I'm then going to do cross multiplication. So the x squared is going to go up there. Whoopsie. And the 200 is going to go over there. And so I'm just putting it over here. So that's going to eventually give us 32 times 200, which is 6,400. And x squared. You then get x alone, and that's going to give you plus and minus, but you don't have to say the minus because I'm sure this person can't drive at a negative speed, so you're going to get 80. Therefore, this dude is going to travel at 80 kilometers per hour. And that is how we do that question. In this question, we are told that A and B are independent. Kevin, what does that mean? Guys, to be honest, independent is a really weird thing, but what I want you guys to remember is that when they say that, it means the following formula is true. So it means that the probability of A and B is the same as probability of A times B. When you see independent, just write that down, okay? Now it says P of A and B is 0.3. Okay, great. P of only B is 0.2. Then it says, are A and B mutually exclusive? Motivate your answer. So mutually exclusive looks like this on a Venn diagram. So it's like A and B cannot overlap. You know, guys, I'm going to say something now, and so like 10 years ago, I would always use the example of, when in real life, this is like being a male and being a female. But honestly, when I want to mention this now in today's times, I'm like, holy crap, I can't mention this stuff anymore. Like, people are now helicopters, penguins, squirrels, male and female in one. I can't, him and her and they. So I got to be so careful these days. So I'm thinking of a good example. Okay, let's say we are at a school and you're only allowed to play. Oh no, I got to use a good example. Okay, I've got it. People at a school who do maths and maths literacy. You can't do both, right? So there will be no people who do both. So this is what mutually exclusive looks like. It means that the probability of A and B will be equal to 0. That is what mutually exclusive means. If we have mutually exclusive, it means that the probability that someone does maths and maths literacy is 0. So we say P of A and B equals 0. But now they've told us that P of A and B is not 0. They've told us that it's 0.3. So we would say, no, it's not mutually exclusive. And then we'd say because P of A and B is not equal to 0. So yeah, guys, I no longer use the male-female example anymore, but like 10 years ago, or not 10 years ago, I wasn't even teaching 10 years ago, God, about 5 years ago, when I was teaching, I would comfortably say, yeah, so the males and the females, but times are interesting these days, hey, times are different, so I gotta be careful. Gotta be careful of the cancel culture. So what we need to do now for this next question, only A, is I would advise that we draw a Venn diagram. So we know that the circles are gonna overlap because we know that they're not mutually exclusive. So we can say A and B. Now they've told us that B only is 0.2. Now be careful. What does only B mean? Only B is this part. Some students think that it's all of this, but that's not true. It's this part here. So only B is 0.2. Okay? Then it says probability of A and B is 0.3, so that's this part over here. And then some students are just going to go fill this in and say 0.5. But you've got to be careful. There might be stuff on the outside. So to work out probability of A, we could use this formula over here, because they told us that these events are independent. But remember that when they say A, they are meaning the whole of A. The whole of A. So that's all of this. And when they're saying the probability of B, they mean the whole of B, which is all of that. Okay? These parts here aren't the only. They're not only. So we know that probability of A and B is 0.3. We've been told that. Probability of A, we don't know what that is. And then B is all of B, so that's these two together, so that's 0.5. And now you can go work out the probability of A, which will be 0.3 over 0.5, which will be 0.6. That doesn't mean we're going to put 0.6 there. What that means is that the whole of A is 0.6. So that means this one will be 0.3. Now, if you had to go add this all up, you would see that that only gives you 0.8, and so the outside must be a 0.2, so that all of the decimals add up to 1, because that's what probability does. It always adds up to 1. So, if they want us to find now the probability of A, so you could show this in the test how you did that, and then from your Venn diagram, you could then just say only A is this part over here, and so your answer would be 0.3, but you would show the Venn diagram. Or you wouldn't actually have to show the Venn diagram if you didn't want to. You could also do this. You could do what we did here, equals to P of A times by 0.5, and then you could work out the probability of A as 0.6, and then you could just say 0.6 minus this 0.3, which was over there, and that would give you 0.3. Okay, then the last one is probability of not A or not B. So not A or not B. So we need to remember the formula for OR. OR goes like this. So the OR formula is on your formula sheet as the following. Where this part here is OR and this part here is AND. But now we need to be careful. The two events that they want is not A and not B. So I need to go change it to not A or not B equals to not A. Oh, I'm going to run out of space. Okay, I'm going to try to squeeze it in here. So, guys, for my not A, I'm going to say like this. I'm going to put a little line like that. That means not. Okay? Not B. Okay, because that's what they wanted. This is just the generic formula that we have on our formula sheet. Right, and this is what we're trying to solve. So, we need to see not A. So, not A, so if you look on your Venn diagram, where's not A? Well, it's everything besides A. So, not A would be 0.2 and 0.2, so that's 0.4. Then it says not B. Okay, so not B is everything besides B, so that's 0.5, because there's this and this. And then it says not A and not B. So think about that. Where are the places on this diagram that are not in A and they also not in B? So that would only be this part. Not in A, so it's not allowed to be in A, and it's okay, so it's not allowed to be an A, and it's also not allowed to be an B. So that means it's 0.2, which is the one on the outside. And if we had to go work this out, we end up with 0.7. So here we have a teacher who has 5 different poetry books, 4 different dramas, and 3 novels. Okay, so I'm just going to say, okay, so we've got 12 books. So 3, let's just actually go draw this out for ourselves. So 5 books, 4 drama books, and 3 novels. So I'm just going to go P1 for poetry, P2, P3, P4, P5. Then we've also got some drama books, drama, 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 and drama, and then 3 novels. Okay, so it says write down the probability that a novel will be the first book placed on a shelf. Well, out of the possible, so imagine you've got these 12 books in front of you, 3 of them are novels, so there would be a 3 out of 12 chance that you would choose that one, which would then obviously break down to 1 over 4 after you simplify. So that's this question done, so that was 1 over 4. Then the next question is, for 2 marks, calculate the number of different ways that these 12 books can be placed if any book can be placed in any position. Okay, so there's no repetition. Remember, these books are all different. I mean, they even said here, different. So it's like Macbeth, The Great Gatsby, I don't know, The Crucible. I don't know what books you guys read these days, but they're different books, okay? So if you have 12 different things in front of you and you have to arrange them, your answer is just going to be 12 factorial. Or you could say 12 times 11 times 10 times 9 times 8. But we're not going to divide or anything like that. There's no repetition. And so that's a big number, 479001600. Now, with this last question, it says calculate the probability that a poetry book is placed in the first position, 3 novels are placed next to each other, and a drama book is placed in the last position. So let's just draw them out again. Right, now we've got 12 different spots available. Now, these novels, they're going to be together. They've asked us that those will please be together. We know that the first one is going to be a poetry book and the last one is a drama book. So let's go do those ones first, the poetry book and the drama book. So for the poetry position, they want the first position to be poetry book, so there are 5 different options over there. Okay, and then for the drama book, there would be 4 different options over there. Now, so we're going to say our answer is definitely going to have a 5 times 4 in it. Now, for the remaining parts, let's say we chose this one and let's say we chose that one for the drama and the poetry. Now what you got to do is you got to look at how many groups do we now have. So this is 1, 2, 3, 4, 5, 6, 7. This is its own group. So that's one group. So that means we have 8 groups in total. So we say 8 factorial. I've done some of these with you guys before where we talk about all these different groups and how to do it. So that's 8 factorial. And then within this group, there are 3 things. So you would say 3 factorial because there are 3 things within that group. Okay? Now if you had to go work this out, you're going to end up with 4838,400. But now they've asked us for the probability, so we should also divide this now by the total probability or the total number without the restriction, and that will give us 1 out of 99 as our final answer for that one.